Right, good afternoon, all my distance students. I hope you are doing well. I've given a class to my students that are on campus, and I would just like to also for you do the same class. I hope you're all doing well with Project One. Just want to remind you that Project One then is due this Thursday. You must be reminded that you have to upload Project One by 5 o'clock and then just follow the instructions really well and make sure that you fill in all the relevant forms that we want from you and that you followed all the instructions. We are going to start with Project 2 this week. And just as a background, I would like to give you a bit of information on API development in terms of, just architectural principles and so forth that helps us to understand what it's all about. Right. So if you think about, where APIs come, we're mainly talking about web APIs, and the impact that web APIs can have on the profitability of a company. We all know who Jeff Bezos was. He still is, he's the CEO of Amazon. That is a massive, big company today with, doing infrastructure as a service, cloud computing leader. They are the leaders in the field. We all know that, and many companies are being hosted from their sites. But many years ago, Amazon was just a bookstore, but one day he decided around 2002, which is a long time ago, that was when APIs just came out. So he told them that all teams will now expose their data and functionality through a service interface, every single team. Every single team must communicate with each other through the interface. And no other form of communication is allowed. No direct linking, no direct reads of data stores, no shared memory models, no backdoors of any kind. Only through interface calls. It doesn't matter what technology they use, and they must be designed from the ground up to be externalized. In other words, anybody from the outside, it should be made public. There are no exceptions. And basically, he closed the mandate with anyone who does not do this will be fired. Thank you. Have a nice day. So we know what successes came from this whole thing, and this is the impact that APIs can have on your company and your organization, and why we have to design these things very well. So even if you were a human resources department and you needed some information from marketing, you had to get that information through an API. So every team becomes, in this situation, a partner of the other. So yeah, you can imagine that, if your API is the only way in how people now communicate with you, you must make sure it works very well. It is up all the time, and that people can trust it, and you think about when you make use of external APIs that are on the internet, public APIs, that sometimes can be very unreliable because they are not always well maintained and you have no idea how to contact the developers. But yeah, so if you want to really expose functionality in a way that you can make some money out of it, you must make sure that it's very stable and it's always available. And that gives you that competitor edge that you need in a company. So yeah, this is a nice success story of how APIs can change your whole business. And this was internal APIs within Amazon. So what we know is the API then are components that are loosely coupled. So I'm going to talk about this a bit more. We talk about web APIs that are then, mobile apps, cloud apps, web apps, and whatever. And they are used for machine-to-machine communication. But when we show them to someone, we are not showing them to customers or clients, but we are showing them to developers who are going to now pull them into our applications. So API design is very important because when you want to make a change afterwards, changes are difficult, expensive, and time intensive. So when you've actually created your API, you've gone a lot of trouble to design the code and implement it, and you expose it to someone for like a year and you change it. It means that if you change your interface, they have to change and code can break. So we have to be very careful on how we do this. And that is why there's an approach we called contract first design approach, where instead of just starting to write your code and delving into the details and the nitty-gritties, you sit down and you think about what it is that you want your API to expose to the outside world, and you make sure that that interface is solid. It doesn't change. It will accommodate anything that would happen in the future. So, you know, code can obviously change. Whatever happens behind the interface is up to you. You can change there whatever you like. But the interface you expose to others that they are going to be working through with you, that is something that you have to make sure is very stable. Yeah, so and you are exposing this to developers. You must make sure they understand what you are doing, and that is why we are using specifications like Open API, and a tool like Swagger for that purpose, which we'll get to. Now, if you think about the hardware industry, you know, if I go and buy a keyboard, I can make that keyboard plug into any PC. You know, so, you know, I want to call a keyboard loosely coupled. It's not coupled to anything. You know, whenever, obviously it can only work with any device that has a keyboard interface, but it will work with any. You can take any keyboard from any company and plug it into any machine and it will work. Now, that is where things really can, you know, grow and become more flexible. If we could build software in that way, that whatever you, you know, expose to others, that you can plug it in anywhere and use it. It's like a black box. You don't have to know how it works, but it works. If we can write software like that, that is where we can really, you know, become more productive and increase profit margins a lot, because things happen faster. You don't have to rebuild code. You know, it's a much better environment to work in. Now, for our purposes, we are doing an IoT device management system. You know, so we are going to be, and you can see we are doing this part of the system for project 2. And here we have endpoints. Okay, these endpoints are then the interfaces that I'm talking about that are being exposed to developers who are going to be implementing code that is going to be calling our API and that is going to be accessing our resources at the back end. And so, yeah, this is a very important point of contact that we have to design well. Architectural design principles that I would like you to know about, well, just one actually, is loose coupling, and below that, a part of loose coupling is asynchronous communication. These are very important concepts for us to know in this environment. So what does loose coupling mean? It's an architectural principle where we say that components have to be independent from each other, and when you make changes in the one, it does not affect the others, because this ensures flexibility and reusability. And the more dependencies you have between the services, the more likely it is that when you make a change, there will be far-reaching consequences for your environment. And you know, you don't want to be that person, that developer, who changes one line of code and then all of a sudden the whole application breaks. So that's what you want to avoid. So if you look at this diagram with the circles that have been intertwined here, you know, you can see they all touch each other. So that means there's dependencies between all of them. And if I change something here, you never know that will happen there. So this is very tight coupling. Loose coupling is, here I have 4 different components. They do not touch each other. There are no dependencies, but they only communicate through information that flows. In other words, messages that are going up and down. So if I should change something there, the chances are that nothing will be affected in the others. So there's not that much coordination and so on. And so this is a far better way of designing my components or my services or whatever you are designing. So we need loose coupling in the first place for performance, scalability, and elasticity. You know, you think about performance, what is your slowest component? That is the thing that will keep you back in terms of performance and the ability to scale. And very often that is our database. You know, if you think about it, that in a company, all components in the end will interact with the data in the database. So if the database is slow or the database crashes, everything is affected. You know, so how do we make, you know, create components that are loosely coupled from the database? That is something else to consider. And in microservices, they have a pattern called the database per service, where every service has its own database, which does accommodate that. But that's a very extreme solution for this problem, and we don't see this often. But yeah, so you want to make sure that you are not dependent on other components for your performance. Every component runs by itself. Okay, and then productivity, you know, if things are very loosely coupled from each other, you can deploy much quicker because they are isolated. And then as you have less and less dependencies between your components, you can make changes very quickly and you can have deployments happening very fast. So loose coupling is a very important principle to design any application with to make sure that these factors are then improved. So how do you know if your services are loosely coupled? These are some questions you can ask yourself and you can see what your answer is. Can you deploy a service independently regardless of any other service? Can you test and verify your services without using an integrated environment where they're all tested together? Can you make a large-scale change to any internals of a service without referencing another service? And if a service stops, will it prevent others from running? So these questions give us a very good idea of what sort of a measure of how loosely coupled our services are. So if one is always referencing the other and calling the other, then we know we have a problem. So if one of them should crash, the others will crash. And that is what you try to avoid. So it's a very important thing to consider when you design your code. How interdependent is it with the other parts of the code, so that I can prevent this sort of thing from happening. So how do we make sure that, loose coupling is applied in a system? We need to look at 4 factors. The first one is that the messages that go up and down between our services are vendor independent, in other words, not related to a company like Microsoft or something like that. Platform independent, it doesn't matter what operating system we are running on. They are coarse-grained, in other words, it's not lots of small messages going up and down all the time. Self-describing, in other words, you look at it and you can see what it is. You don't have to try to figure it out. Self-contained, in other words, as the message is there by itself, it is all that you need to be able to process whatever has to happen. And stateless means that there's no state between the client and the server that is being maintained. So those are the, so obviously something like HTTP, for example, measures well against that requirement. And if you then use HTTP as a messaging protocol between services, it means that you are enhancing loose coupling. Then interfaces that are well-defined, extensible, versionable, and constrained. In other words, you know exactly what the interface is about, and you can see what version of an interface you are working with if changes would have happened. Then addresses that are URIs, because everyone understands them, and we can uniquely identify any resource on the internet with a URI. And then exchange patterns that are asynchronous when possible and appropriate. We'll talk about asynchronous now. So let's look at that HTTP request that you see down there. It's an interface actually. So what from this we clearly see that we have a HTTP as a protocol here. We have a server, API, version 1, users, and 1, 2, 3, 4. In other words, I want to access user 1, 2, 3, 4 from the user's resource. Now, this does comply to most of the requirements that I've listed here. It is a loosely coupled type of interaction that I'm seeing because I'm using HTTP that is vendor independent, it's platform independent, it's self-describing, it's self-contained, and depending on how I implemented it, is stateless. The interface is versionable, it's well-defined, I can see what it means. This address is a URI. And depending on how I implement it, it could be asynchronous. So yeah, when we are looking at these requirements, we can see, okay, well, when I use an API interface like this, I am enhancing loose coupling in my system. That is exactly why Jeff Bezos decided to go for this approach in 2002. He realized all these implications and he knew that if he could get everybody in his company to adhere to this, he's going to create an environment that's going to grow and that's going to expand and that's going to be scalable. So yeah, loose coupling is definitely enhanced through REST type of interfaces. Now let's talk about the exchange patterns. There are 2 types of exchange patterns that we normally see. Synchronous calls are when it's like a telephone call. I call you, I dial your number, you pick up, and then you talk to me, and while I'm busy with you, you can't do anything else. You are busy on the call until you say the call is finished, and then you put your phone down and the call is done. That is synchronous. It is being linked in time. So when we are looking at this synchronous call, you can see the client sends a request to the server, and the server is going to do some work, but now the client can do nothing in this time. And when the server now responds, then the client can continue and do something here. So in other words, here is a block of time where the client has to wait for the server to do its work until it receives the response. And then if nothing happens, you may get a timeout. But synchronous means it's a constant interaction happening and the one has to wait for the other one. Now, on the unreliable internet, as we see it, this is not the best approach because, you could wait for something for very long before you get an answer or never get an answer. So you sit there and you can't do much. So this is not a good way of implementing calls on the internet. Whereas with asynchronous communication is when I, as a client, make a call to the server, you can see I'm going to make a call to you and then you're going to be doing work, but I'm now going to be doing something else. I'm just going to be continuing with whatever I do. One of the implementations is fire and forget. I will just give you something and then you can continue. And this is similar to email. When I send someone an email, I can continue with my work. They can answer it whenever they have time. And then they can give me an answer and I will just have to wait. And when that happens, but in the meantime, I can continue with my work. And obviously on the internet, this is a much better implementation to use because now my client can actually be busy with something else until an answer is received from the server. Right, so in the programming that we do, and this is something that you will see is sort of just automatically enabled in the framework that we are going to be using, in the ASP.NET Core framework with C#. Basically it's all about threading. That an execution thread should not wait for an IO-bound or CPU-bound task that's going to take a while, okay? So IO-bound operations, for example, are file accesses, database accesses, or HTTP requests that is going to take up a lot of effort. Now, there is something called async await. That is the code that we use. And essentially, what this means is that I will be able, if I implement this, to handle many more requests than there are available threads. I'm not going to keep hog threads while something's happening. So, in a synchronous process where this is not applicable, the next activity will be blocked until the current activity completes. In other words, the thread is busy. And asynchronous means the task can complete in the background, that can continue. There's not a thread waiting for it. And then when it returns, then you will continue with your processing. So let's see what it looks like in ASP.NET Core. So what we see is, there's a request, it calls, makes a request and a thread is invoked and then it is blocked and it will wait until whatever happens on the database side. Let's say this is a database call. Then there's a second request that sort of is going to be used by thread 2, which is also then blocked and it will continue. And then it could happen that your thread pool runs out and everything will just sit there until, results are returned and the thread can be returned back. But in asynchronous, a thread from the thread pool that will handle the requests. Okay, so there is a thread that will handle these requests and they will all be waiting. Okay, so in other words, these threads are all now free. So in other words, many more requests can be made for the thread pool that there is. And then when the results come back, then a thread will be assigned and then the request will be processed. So it's all about, managing the threading a bit and making sure that nothing sits and waits and hogs for that implementation. Right, so those are the design principles we just have to keep in the back of our minds that we need to implement. You need to think about loose coupling. That is why you do the web APIs. And secondly, the asynchronous implementation, not hogging threads for work. Okay, now think about our device management project. This is sort of a company that you see here, and they are using a lot of different type of devices. And in the end, what we need to do is we need to have a management system for these devices. And there are many frameworks today out there that does this for us. It's a big sort of environment that is available. like AWS has got one, Azure has got one. Yeah, so there are many companies that provide these monitoring systems for us. So essentially in device management, you need to do the following, and you need to register a device, get it on board and make sure it's registered and it's assigned somewhere, configure and provision it, send and receive data, and do some analytics. And a lot of these things we will be implementing from project 2 to project 5. So when you register your device, you're going to, make sure that it's connected to your web for the first time, so you put it on the web and that you can actually track it and you know where it is and you can communicate. Essentially, you want to communicate with it. And then you can send and receive data either through a specific protocol called MQTT, which is much better for low resource devices, that are restricted. It's a really good protocol, or you can use HTTP. Now, in our case, we are going to assume that all our devices are HTTP enabled. In other words, the device, let's say like a fridge or a bulb or a light or whatever it is that you are enabling with the internet protocol, that device has the ability as a hardware device to its sensor information can be processed via a HTTP interface so that it can communicate with an environment. So here we have an idea how that would work, that you have this is obviously not your device, this is its interface, but there's some light bulb here, but this device can send communication and some information like whether it's on and off, it can send this to a service. So that is essentially what this project is about. And then I would like to talk, just to end off with, about API design issues. This is very important that we design our APIs in the right way, following best practice. And I've put together a lot of points for you that are very important to follow and that you should be very careful when you do it. Now, first of all, let's have a look at an API that is wrong. Now, this was a Twitter version 1.1. It's a while ago already. But this API of Twitter only made use of get and post for interacting. They didn't use the other commands. But let's, for example, see if you want to delete a status, what they said is they said post, statuses, destroy, status ID. So what they were doing, remember what is post supposed to be doing? So post is when you, for example, log in. So when you're doing a post, it means that you take parameters like a username and password, you send it to the server, and some action is invoked, some function that will now check whether you are a registered user. That is what post is supposed to be. Post is not supposed to do any deletes. So the right way of using this command would have been delete, statuses, status ID. Now, the minute we see a verb in an interface, we know there's a problem. So this was the big problem, that you are using a HTTP command in the wrong way. You are trying to delete something using the destroy command, whereas you could have just said delete statuses, status ID. So yeah, so this shows you that even big companies like that make these sorts of mistakes, but that was a while ago, because best practice wasn't that well established as it is today. Okay, so what are the principles when designing APIs? First of all, keep it simple. In other words, if I have a resource like products, there are only 2 base URLs per resource that would ever exist. So I have products, or I have products 1, 2, 3, 4, 5, meaning a specific product. So either all the products or just one product. That is the only 2 URLs per resource that you can start with. Secondly, we use nouns and not verbs. So for example, products will just be products, get products, and not something like get all products. We will use plurals, not singular. We won't use product. And then we will use parameters. If you want to get a specific product, you will not say get product by name. You would rather say, I want to get the products, but I'm going to use a property name. I want to get specific ones by name. Yeah, so never put something like that, get products by name as an interface. It has to be products and then something that you will manipulate that. So when you now have 2 base URLs, you have 4 ATT verbs. So there are your 2 base URLs, dogs and dogs 1, 2, 3. And now you've got post, get, put, and delete. So in the end, all that one can do is you can combine all these things with each other to get to all the interfaces that is possible on a specific resource. So we could say, I can create a new doc by saying post docs. I can get a doc by saying get, and that'll get me all the docs. I can update something by a bulk update on all the docs. You want to change something for all of them, or I want to delete all docs. But for a specific doc, I cannot do a post because you actually have to get that. It has to exist before the time if you want to do that. I can get a specific doc. I can update a specific doc, and I can delete a specific doc if it is there. Yeah, so therefore, this is a very good diagram. You have 2 base URLs. You've got 4 verbs, and that's basically what you can do. Okay. When we also, use our names, we must be more specific. So instead of saying items, you should say something like videos. Like Twitter, they, for example, talked about statuses, whereas they should have rather talked about tweets. So when you design your interface, use a proper name for whatever it is you are busy with. Don't try to make it very general because people will get confused later on. Okay, now when there is associations between resources, this is how you should do it. So for example, docs belong to owners, so you want to have for example, get resources, get all the docs belonging to a specific owner. And this is how you will do it. For example, I would say owner, a specific owner, and all his dogs, or I can do a post as well. So this is showing relationships. In other words, whenever we have a relationship, we will have resource, identifier, resource. And this is how we implement accesses to more than one resource from an interface. So what happens in the background is in the code. But we now see, okay, we are going to be using the owners and the dogs resources. A specific owner has many dogs perhaps, and that is what we want to get here. To get all dogs in the red dogs running in the park, you would then obviously just have something like a query string to say that where the color is red, it is running and it's in the park, then get me that. And that is then, that's just a proper query that you're running for just on one resource. Okay, so handling errors. This is a very important thing. Errors are returned to developers. And if I look at these 3 errors, this is then, we have to rate them according what is the best one. This is what we can see. So this one is Facebook. It's an error, but it says here 200. Now 200 means it's successful. So I have a successful code, but I have an error, which obviously is wrong. So that doesn't look right. Then I have Twilio. Okay, here's a status code 401. It means there's some problem. So I can see there is a status 401, there's something on authentication, then there is a code, and then I say, here's a link that you as a developer can read on this error to get more information. So this error is returning really good information to the developer to sort out this problem. And then here's another one, it just says it's a 401 authentication required. So this is a very basic one. So of these 3, basically the Twilio one will be the better one for the developer because I can open up a document and read up exactly what the problem is. So I'm giving you more information so that you can sort out the problem much better. So obviously, you must carefully design your errors so that people can get to the essence of the problem. Yeah, and so this is just saying, there are 70 errors, but we just have to make sure in the end we don't use, we just use some basic error codes, but make sure that you handle errors in the right way. And here you can see if you are just sending an error back for a computer, 200 or 400, 401 will be fine. But if I'm sending a message for people, this is the sort of error, you want to have a lot of information so that they can sort of, a developer getting that will be very stressed and very unhappy, whereas a developer getting this is going to be very happy and it's going to be able to do something about it. So yeah, errors should be done properly. Then versioning, we use always with any interface, always a version number so that when changes happen, you can sort it out. So let's say a change happens, you can let your people know, okay, well, I now have version 2. version 1 will still be maintained for another few months, but then you must be on version 2, and then people exactly know what version you are using. But avoid using version 1.2 or something like that, because it looks like it's going to change a lot and it's not going to be good for your reputation of your service. Pagination is getting information back. If you are getting a lot of information back, you want to get it back in sets. Like, for example, you could say, give me every 25 records. That is when you'll use pagination. So you sometimes have to know about that. And then we mainly use JSON. JSON is the sort of standard, and we use OpenEye specifications, which we'll talk about, to specify how our whole service will look like. And then lastly, we need to have an entry point where all the information is. It's like the homepage of the API, which I already showed you before. And then we mainly use formats like this, API.com star or API. Here we have API star, which means there are security implications. And so here we see on Postman, for example, api.github.com, and here you can see this is the root API giving you this information. And here you can clearly see how all the interfaces look of all these different URIs that I see there that are calling specific resources that are available for somebody to use. And you can then view them all and see how they work. Right, so just lastly, let's just say that I want to build a fictional API, and what I have here is I have many zoos, and many zoos have many employees working on them. A zoo has got many animals, and the animals are of a type. So you want to now design the APIs for this. So basically, you have 5 endpoints. You'll have version 1 for the zoos, the animals, the animal types, and the employees. And now from this, you can now say, okay, what is it that I want to have from each of these specific endpoints? Yeah, you can see that, for example, I want to get all the zoos. I want to create a new zoo. I want to get a specific zoo. I want to update a specific zoo. I want to update partial resource patches. Then we don't really use patch that much, but it's again an update. Or I want to delete a specific zoo. So down here, you can, for example, see that I want to get for a specific zoo, the employees, and this is the relationship between them. Yeah, so this is a very nice and tidy set of URIs that I see here that are accessing my resources, and this is following best practice. So this is typically how the endpoints of any of your services should look like, and it should be structured in this way. This does not always come naturally to software developers. We are busy always implementing functions like get this, calculate that, process that. And so many people will go and put those types of words in their API interface. But that is not the right way of doing it. I just want to make you aware of that. Now, when we are using our tool, the tool will create the right endpoint for you. You don't have to actually do it. But if you are going to write an API from scratch, you must remember that this is something that is important to be able to do right. So I hope that is information that, will help you. And it's just some background information to understand the environment a little bit better and to help you to become a better developer, to be more aware of things. Very often if we take a tool and we just start clicking and configuring and dragging and dropping, we lose a sense of what is really happening and what is really important. So yeah, so I thought I'd just give this background to you. Right, so I hope that you will have a good week, and I hope, we'll start Project 2 this week. With Project 2, we'll start on Thursday, and then we'll show you more information. So yeah, this is then all from me, and have a good week. So I'm now going to redo the class for the benefit of everybody who would like to see it again. So I apologize for that, but it probably looks like a Microsoft Teams issue that was not just related to us, but to most people using it. Okay, so just quickly, let's redo the slides and then we will get into the demo. So for Project 2, we are doing a CRUD RESTful API that will connect to a database that stores IoT device data. So we have 3 tables in the database. the device table, the categories table, and the zone table where the data, the IoT device is then located. And so what we are focusing on is the CRUD service. And so what does CRUD stand for? As you can see, CRUD is basically the 4 HTTP methods that we have to create, which is using post, to read, which is using get, to update, which is using put, and to delete, which is just delete. So we need to understand what is a CRUD service. That is the most pervasive type of APIs that we see today, and how to implement them. So you should go and read Project 2, the brief, and you will see all the requirements that you need to apply in your project. Now, to understand where CRUD services lie in the whole RESTful architecture that we consider, we need to look at it, and holistically there was a guy called Richardson. He then defined this maturity model, and he started at level 0 and then worked up to level 3, which is HATIOS, which is not something that's actually the ideal framework or sort of implementation of RESTful services, which we don't really see much. But let's have a look at each of these levels. So level 0 is essentially where you just move out of your normal programming environment, where you are used to making calls to functions and procedures. And those things have a sort of a verb as a name. You call them and they may do quite a big job for you. And so essentially this is where SOAP services actually lie. So SOAP services are very sort of poor in how they actually comply to the maturity model of RESTful services. So basically, let's say there's an appointment service. You can see here is an appointment service. It is a massive big service that can do lots for us. And so what we do is all the time we invoke it through parameters. Like you can see, I'm asking for an appointment with a certain date with a certain doctor. So I'm sending this information to the service, and this service will answer me. And then I can again request more information out of it. So, I'm just using a REST as a normal way of invoking procedures. And that is not really what we should be doing, but this is initially how it started. And there will still be people out there that will do this, but they are using a very low level, maturity level in terms of what should be done. Then things can improve a little bit, and we can say, okay, well, we know we have to access resources. That's the requirement. One of the constraints of RESTful services is that we actually should access resources. Okay, so here we see a post, but it's asking for a specific resource slots. So in my database, there is a slots table where all the slots are of times where you can make appointments for a doctor. And so what we now say is, okay, I actually want to find slot 1, 2, 3, 4. In other words, I want to go in, I want to book that slot for a certain patient, which you can see is Jay Smith. So what we now see is that this can change a lot. So I can be requesting different slots all the time. So I will have many URIs, because this is the URI and it will be changing all the time, but I'm still only using post. I'm not actually using any of the other commands. And so this is level 1. We are doing resources, but in a very basic way. Now we get to level 2, where we are using now, this is what we generally would do when we are developing. And remember, if I say a RESTful service and an API, it is the same thing. So what we now have is CRUD services. Now CRUD means we are using all the HTTP commands. So you can see I'm using get and post, and I could put and delete here as well. And then for them, I'm using different or numerous URIs. So you can see I'm using the slots again. This thing can change a lot, and you can see that can change a lot. So my URIs are changing all the time. I'm using all the verbs, and this is typically a CRUD service. So I'm updating my resources in all different ways. So this is where we basically sit today, and we do this type of implementation. And finally, we have HATIOS. Now, HATIOS stands for where we basically hypermedia is the first word, hypermedia application integration that we have. So basically what it means is that we are now supporting hypermedia as the engine of application state. So it's hypermedia as the engine of application state. Okay, so that's basically where the acronym comes from. Yeah, so it's an engine. So it's an engine that will execute, and we talk about application state that changes all the time. And so, as I mentioned before, REST has also got the word state in. So as I link between different pages, each time the state will change. Now, in this case of, making an appointment with the doctor, what I'm saying is please get me the slots for Dr. Jones. So all the different slots. I want to make a booking with him. And so what will happen is I will return, yes, here are all the slots. So you can either book slot 1, 2, 3 or 5, 6, 7, 8. So what I'm returning is, I'm returning links. And now, just like when a person is browsing on a browser, the internet, as you browse, you click on a link, you get a page, and that page got new links. You click on one of those links, you get a new page, and that page has got new links. And so as you as a person, you are browsing the internet. What we are now saying is that no, code is now going to browse the internet. In other words, when this return comes, the code is going to read it, and the code is going to say, oh, here's a link and here's a link. Let's display to the user. The user will click on each of these and then send the result back. So these links are dynamic. They change all the time. These links are not known beforehand. In other words, we decouple the client and the server from each other in time. And, in the state changes all the time. So it's very good for loose coupling. Yeah, so this is implemented by, for example, PayPal. They have implemented this in their applications. And if you want to implement your applications in a more flexible manner, this is obviously the way to go, because you are not then sort of dependent on others for the addresses or the URIs of what you have to do. And yeah, this is a little summary of, so basically we are sitting over there, and this is where our project will lie. Okay, and that's just building CRUD services. Then, you've got all the verbs and you've got your URI template that is very standard that you use in that way. Okay, so when we're looking at hypermedia, let's just look at 2 examples. It's a question of you move from one state to the next. So, the code will call the server returns links. The client application chooses a link, returns to the server, that new server will return more links, and so it will continue. And what's interesting about this is that you do not know where your code may be going. It's something that is not under your control, because you are getting these links back, and therefore, as you reach a new state, your new transitions are possible. So it's a very interesting way of looking at the web as the engine of applications that are stateful. Yeah, so it's a very interesting concept, and I think it's something that will grow in the future. So therefore, if something is returned to you, it could be that I return the information about a person, and now I say, you know what, if you want to manipulate this person, if you want to call him his information, this is the link to use. If you want to delete him, this is the link to use. And if you want to change something, that is the link to use. So now these links are dynamically sent to me. I don't have to know them beforehand. They can change. So in the background, these things can change. So you decouple the client and the server. Here's another example. Let's say I have a bank balance, and this bank balance is 100, and this bank balance is in deficit, minus 25. So when I call my bank balance, it will display to me, okay, you've got 100 Rand. And then it's going to say, well, if you want to deposit, here's the link. If you want to withdraw, here's the link. If you want to transfer, if you want to close your account, those are the links. Because you've got 100 Rand, so you can do all those things. But if you should have a deficit, you cannot actually deposit. So deposit is you can deposit, yeah. You cannot withdraw, you cannot transfer, and you cannot close. You cannot close your account with that. So therefore, the only viable link that you may do because of your balance is then displayed to you. And so you can see how dynamically we can manipulate what is supposed to be available to the client, and that we can change this as we go on. So yeah, this is an interesting way of looking at things. In terms of the demo, so we are running our applications on ASP.NET Core. And there are some new concepts that we have to introduce that will be important for you to understand to be able to do the demo. There's a link here on this page on Stack Overflow that you can have a look at, which is very interesting, which gives a survey of 80,000 developers on how they see popular technologies. And yeah, the technologies that we are using in the course is actually quite high on the list. You know, the cloud that we are going to be using, the web frameworks and so forth. So have a look at that and just see, you know, what is going on and what is important for you to know. So we are going to be discussing what are controllers, the Entity Framework Core, and Swagger. Those are the new techniques and things that we are introducing here. Right, ASP.NET Web API controllers. These are then controllers that we find in a pattern, a software design pattern called the Model View Controller. It is a pattern that has been around for a while already. It's not new, but you're going to see how it is being implemented when we implement APIs. Okay, so in this environment, what we then define it as is controllers are a main entry point to handle all the interaction. So actions come out of controllers and logic is performed there. And then data state is handled in the model. So for our purposes, for the API project, we are only looking at controllers and models. And then when you do the client in project 3, you're going to be looking at views. Views are then how data is presented. So for our purposes, we are looking at those two in the API development. Okay, so it's basically a way of grouping endpoints. So yeah, so we know that when we talk about an endpoint is an address, and that is the interface then of your API. And so, you know, if I think about there is a resource called categories table. So I'm going to have a categories controller, and I'm going to have a number of endpoints to get, to put, to delete, and so forth on that endpoint. And so there's a folder on your API environment where you have a controllers folder, and then you are going to derive this from the API controller class. So it will typically look like this. So here we see that I'm going to be routing to my controller, inheriting from API controller. And in this case, I'm going to implement the students controller. In other words, I'm updating the students resource, and I'm going to have endpoints get all students, a specific student, post, put, or delete. So these are my endpoints. So this is a grouping of endpoints per resource. And yeah, so when a call comes into my server, it will be something like get, HTTP get, and then my address, my URI. And so in the URI, the web server will then process this and say, okay, what must I do with this get? So, oh, here, I see I have to get, you know, on the API, I have to get the student resource. So it's going to then branch off to the student controller. Oh, what must I do? A get. It will actually go to the get method. And the same for the post. You can see it goes to the post method. So that is how these routing, the API web routing then works using controllers. And that is what we will implement in the code. Then secondly, the Entity Framework Core. So this is a way of handling your data from your database inside the application. So we call it an Object Relational Mapper, or ORM. And so basically what it does is it takes your relational database and it then creates a mapping to your classes and your software that is inside your application. And so you can now very quickly access the data and update the data using classes. And this leads to a very quick development of database access code. And for our purposes, we assume that you've done enough database courses that you know how to otherwise update the database. And we are going to be showing you a way of quickly exposing your tables, which are resources, using this. And so in the entity framework, you could say then that a table is a .NET class, a column is a property, rows are elements, primary keys are unique instances of classes, foreign keys are just references, and so forth. So everything that we normally would have in a relational database, we would now have in software that we will be able to manipulate in the code. And so essentially what will happen is a database is then taken, and it is basically, we call it scaffold into the class like that using the Entity Framework Core. Now, in the framework, there's two ways of doing this. The one is called the code-first approach, and the second is called the database-first approach. Now, the code-first is when you write your code first and you then access the database. In our case, we are going to use the database-first approach, which is a very easy way of doing this. Mainly, we assume now here that our database has been created and it's not going to change. It's a very static environment. If you have a database that is going to change, this is not a good approach to take. So what happens in the database first approach is that we are going to be creating a modern existing database in the Entity Framework Core and do some reverse engineering. And we are going to be using the scaffold database context command that is going to create the entity and context classes. And so what is database context? It's essentially something that exists to create a session with a database to query and save entities of your instances of your entity to the database. So yeah, it's a connection to the database that's kept there for you where all this information can be then manipulated. And finally, we need to be able to look at our endpoints. You want to see your endpoints and we want to be able to use them without writing a client application. And so there are tools like Swagger and Postman that one can use for this purpose, but we are going to be using Swagger in this demo and in your project too. And we are going to then be able to, let's say you've got an endpoint for a GET, you can then test it here instead of writing a whole client application. Right, for this week then what we want you to do is the training that is available that we provided to you, or any other training that you feel you can do. Any other training that you can see will be able to give you a free credential of some kind. And then what you have to do this week is take what we have explained in this demo. There is a document available on the trainings document, a guidance document that you can also follow with all the code that I'm going to be showing you that you can take from there. And you can then go and create the API with a local database that I'm going to explain to you. And so it's very important for you to finish this week so that you can do it, so that next week on the 25th of August, we are going to be discussing how to now host this in the cloud. And by then you must have been able to implement this. So please don't leave this. You know, the project has to be completed by the 9th of September. There's many things we want you to be doing in the next weeks. And if you leave this step behind, you're going to struggle later on. Right, so now let's get to the actual demo. Okay, so we are going to be creating a new project. So basically, the first thing that we want to do is we want to actually go and the first thing I want to set up first of all is the access to the actual database. So if we look at our database, we are going to be creating in your project 2, a database called the Connected Office Database. So what we are providing you with is we are providing you with a script. Now this script, you will get the link to it. It's a Dropbox link. And this script is then a creation of the Connected Office. You can see it's called the Connected Office Database. And this is the database that you will be using for project 2. And in this database, you'll see there is the category table, the device table, and the zone table. So you'll be creating it. It's got all the necessary constraints in this script, and you can then just execute it, or you can create a new query. You can run it from there. You just paste it in here and you'll be able to run it. But I'm not going to do that now. So for my purposes, I'm going to use a different database today, just as demonstration, where this database is also have a category table, a product table, and a store table. And so I'm just going to demo my API today using that database. So yeah, what we first of all have to do is we must make sure that we actually have a connection string. So that's the first thing to do. So what we do to get a connection string is we are going to create, I'm going to create something called connect. It's a text file. Make sure that you can view file name extensions. And we will now change this into a UDL file that will help us to get to our connection string. It's going to change, double click, and now we are going to set up some properties here. We are going to say, yes, I want to use, I'm not going to put a username and password on, I'm using NT Integrated Security. When we get to the cloud, we are actually going to have to specify username and password. So that will be explained to you later. I'm going to select the following database that will be shown here. So I'm using the products database and I'll say OK. And so it creates my connection. I now have to change this back into a text file. And I now have my connection string here. And so I'm going to keep it here. And this is then from Integrated Security. That is going to be my connection string that I'm going to be using in my project. Right, so that's the first thing to do. Just prepare your actual database connection string. Right, so now we are going to do our API. First of all, open Visual Studio. I've got Visual Studio 22 here. And say you want to create a new project, and we are going to be creating an ASP.NET Core Web API application. And you have to then decide, I'm going to give it this name. So I'm going to call it Demo API. As an example, you can choose anything you like. And then very important, we are now running on this framework, .NET Core 3.1. So when you open this, generally you'll find that there is .NET 6, but for our purposes, we want you to be using 3.1 as it is a very stable version. And it is there's a lot of support for it. If you get stuck on something and you Google a problem, you are going to get the answers. And we will be able to help you with the answers. So if you're not using .NET Core 3.1, we cannot always help you with your problems. And yeah, so that's something that we want you to use. If you want to see what you need to do to get it on your computer, here's a link. It's also in the support documentation I'm providing. But yeah, you need to go to this link, and from here you need to install this SDK and this package here. So then you would have available on your environment here, you will have .NET Core 3.1, and we just check that one. We don't enable Docker. We don't have authentication at this stage. It is something that you can do later on. Right, so we are saying create. Right, so when this has happened, we now can start, and I'm just going to run it. Now here is the default, there's you can see now here is a controller. And the controller that we see here is the weather forecast controller, which is sort of a default application. You can see there is your API, which routes to, you can have the weather forecast controller that's available here. It doesn't really write to anything specific like a database. And yeah, if I run this, this is what's happening. So I run it, I execute it. It's going to then open up my browser, and it's going to display to me this information in a JSON format. So this is essentially information that, I am not supposed to, as a human, look at this. It's not supposed to be on my browser, but a program will invoke the code, and this is then the result that will return to a program that will then display it to the user on a browser. But yeah, this is nothing that I as a user really can do anything with. So that is the basic thing that is there, which we will then basically get rid of. So we can delete this, delete that, and delete that. So you just get rid of that. We are not going to be using that. Okay, and now what we have to do is we now have to install, first of all, the entity framework core that we need for interacting with our database. So we go to the NuGet package manager. And from here, we are now going to install 4 different packages that are going to help us to actually manage. So we go to Browse, and we are going to type Entity Core. So I'm going to start there on Entity Core. And so the very first one I'm going to be adding is the Entity Framework Core package. I check that. But very important here, you must say that you are choosing 3.1.28 and you're going to install it. Okay, and then the next one that we need to install is a .SQL server. And you're going to repeat the process. Make sure you're using the right framework, 3.1.28. And then we need to get the design one. Here is the design one. Again, the same. Okay, and then the last one is the tools. Okay, so you need to install these 4 packages. Okay, install. Right. Okay, so when that is being done, we then can check using, and we can go to, I think it's over here. Here we can see command line interface tools that are available. You can read a little about them. There is a link in your documentation, and you can now see that, we are going to be using .NET EF, and we are going to do the first thing is we are going to type .NET EF there, and I'm going to copy that, and I'm going to be saying, yes, I want to verify here in the package manager console down here on the bottom left. I'm going to say verify the framework. And you can see when that happens, yes, the framework has been verified. Right, so now we know that we are ready to go and we can go to the next step. And the next step basically is, I just have to get to, I want to copy my code. No, not that. Okay, so the next step is I want to now scaffold the database. Now, so basically what it means is that I'm going to scaffold the database to produce an entity framework model from my existing database that I'm busy with. And that is going to basically result in entities that are created, that are mapped. Okay, and the command that we are going to use for that is, like we said in the slides, database context scaffold. And it's going to create a database context and entity types for the database. So in the package manager console, we are going to use the following code. Oh, sorry, what I forgot to do, I was just too hasty there. Okay, I have to go, and over there, I have to put my connection string. So I'm going down here to my connection string, and I need to copy the connection string so that we can use the right database. So I'm going to go back here, and I'm going to replace. Okay, I'm going to start that command again. And I'm going to replace this with the connection string that I've got. There you are, and enter. Okay, now it tells me that my demo API does not reference this. So basically there's something that is not in terms of the packages available. So, so there's now a number of things that we can do here that is possible that can assist us. And I'm just going to show you there's more than one thing to do here. And so first of all, we are going to go to our, let me just click on that one. Okay, so first of all, our project folder file here, you can, for example, put that in and see if that would work. So it will try to pull together the configurations of your files. And we are going to redo this and see if it works. And it still doesn't work. So there's something else that we perhaps can do. And yeah, so the other thing we can do is to make sure that in our startup file, all the references are there. And you can look through the startup file. We'll just put it somewhere here. We need to put in the entity core framework. And so then the last option that I see, okay, well, let's just try this and see what happens. Okay, and then I just would sometimes do that, just run it and compile it. And then that sometimes also works. Okay, so then we're going to try it again. Okay, and now it succeeded. I think if you do that first step, this last step first, it may also work. But yeah, I think you need to put in the actual namespace that you need to have there. Okay, so now that is done. So what we now can look at is now we've scaffolded the database. So the database should now be in the model. So you can see here that the categories file, the table has now been converted into this class that we see here, the products as well as the store. So every table in your database will now be available here to manipulate as a class here. And here is my context file that is sort of a session sort of class that is going to assist me in updating and and it tells me here that my connection string is not supposed to be in source code, which was obviously a problem. And this is where my updates are going to happen, to the database. Right, so now we've done this. We've actually now, and the last step that we have to do is now also add our connection string. We are going to be adding our connection string to the app settings file, and we are just going to be adding it here. And so this is going to assist us later on when we are going to be using, especially I think when we are executing it, we're going to need this. Right, so now we've got that ready, and then we can now go and create our controllers so that we've got our model ready. And so the next step is creating controllers that are going to update the model. So we are going to say I want to add a controller, and I'm going to select API. I'm creating an API, and I'm not going to, you can either do an empty one, which means there is nothing there, you have to write everything, or you're going to have one that already has all the endpoints, get and post and so on. Or you can say, well, I want to add an API controller with all the actions, but using the actual entity framework, in other words, using the models that have been created for me. Okay, and I'm going to say that. So I'm now creating a controller. And remember, controllers are per resource. So I'm going to say I want to create for the category resource using the this context file that I've created, and I'm going to call it categories controller. So I want to add this. Right, and it says that there's again an issue, so there's a problem, and you can't do this. So the issue probably, let's just cancel this, is that when I now go and open the startup file, and when you look in the startup file, it's not referencing. I'll just put in here using, and my thing is called demo API. And we can add that. But my solution is called demo API. It has to reference that as well. And I need to put that in there. Okay, so let's try that again. So let's see. So I need to have that in the startup. I use API with entity framework. I choose the category. I add. So now it seems as if it's working. Right, so now we can see what's happening in here. So here we have our categories controller. So you basically would have a controller for each of your tables. Okay, so what do we see here? We see now here exactly the routing information that I've explained to you. So we are using API controller, and we have this class category controller inheriting from that. And it is enabled here with the DB context as context. Products database. This is then the products database that I defined. Okay, and so what do we see here? We see all our endpoints. So here we see the get endpoint created for all the categories, or for one category, you can see using an ID. I have the put that is updating a specific category. I have the post that is updating the categories table. I have the delete, which is deleting a specific category. So you can see that all your endpoints have been done for you. Essentially, there's nothing much more to do here, if you want to just do basic updates. Now, in project 2, we do request of you to write new endpoints with new code that you will have to then see how to do. Because there's obviously more that one can do than just doing these basic operations. Okay, so all your endpoints are created, and what we also see here, for example, is that when we do, for example, a get, the async await commands have been added. It's also all about asynchronous computing. And asynchronous computing is computing that enables us to not be coupled in time. Okay, so when I, for example, say get category, I'm going to call the database and get all the categories, which can be, it's an IO operation that can, take a bit of time. So what happens is when I see the async and await, then this part is not going to hog a thread and until the whole operation is finished, and then it will return and then it will be displayed. And basically this means that, there are more threads available that can then be used than the requests that are coming in. And the asynchronous type of implementation ensures that your environment is not blocked, doesn't wait for things that have to be done. And everything else can continue. Any other operations can continue. So it's a very nice way of already enabling it in here. You don't have to write it yourself. Right, so everything here I think is basically now done, and we can now see what happens when we execute this and we see if it's going to be displayed. Okay, so now I'm running it and I say, well, it doesn't work. So what we now have to do basically is we now have to add Swagger. So that through Swagger we can interact. We basically want to interact and test these things, but we don't want to write a client application. So that is what Swagger is for. So you will see we've given you a file where you can also reference how to implement Swagger in ASP.NET 3.1 Core. But yeah, let me demonstrate that to you as well. Okay, so what we need now for Swagger, first of all, is we need to add some packages. Okay, and so the one that we need is the OpenAPI package, that one. And yeah, you don't have to worry here about the version. You just take the latest one and install. Okay. And then we need the swashbuckle. That one there. And we install. Okay, so these are the two packages that one needs to actually add to your solution. And now we are going to add in the startup, we are going to add some code. So in the startup at the beginning, you see here is your startup class, and here in terms of configure, wait, let me just add controllers, configure services. Here we want to say, yes, I also want you to make use of Swagger, and we are going to put Swagger in there. And you can change this display here, my test demo API, to see something else on your screen. And then we are going to add to the end of the startup 2 other lines of code. Over here. And we are going to do that. So we are going to use Swagger. And that will be there. Right, so that is what you need to add there. And what you also need to do in the launch settings, you need to change the launch settings file. So if I go here and I type launch settings in the search, I'll get the launch settings file. And so we need to take this whole file and delete it and replace it with this file. And then you have to make sure that this is the name of your solution over here. So this will be demo API. Okay, so we've got all of that together. Right, and now we can see if this will work. Okay, so I'm going to run this. Okay, so now you can see you now can interact with all the different endpoints that you created. So if I should click on get, I could say try it out. So in other words, get all categories. And now you can see I invoke that. And here I get something called a dependency injection. Okay, so now this is an error that is returned to the client. So you sometimes go on websites and you see this sort of error, and the reason is because error handling wasn't implemented properly. You should not be able to, people shouldn't see this type of error, and it doesn't look good. So it's the main reason is error handling should be done better. Right, so there's obviously something else that's still out. And so it's all about dependency injection. So what we actually also have to add into the startup file is something else. So the DB context is an issue. So we go and we add after the add controller. We need to also add in this part. And you can see here the DB context. We are going to say quick actions and refactoring. And we are going to pull it in. And there it is. And there is again your connection string. Right. Okay, and so this thing, let's see if this will work. Let's see if this is going to be fine. Okay, so I'm going to do a get, try it out, execute. Right, and you can see here I have in my database only one record. So here I can get the record, and there is the ID of the category. So there's an ID. So what I, for example, now I could say is let me, okay, let's see, shall I change something on it? So, or find out. Okay, so let me say I'm going to change something there, that 4F, let's make that an 88. So I'm going to update the ID. Oh, yeah, I have to put that in there, sorry. So yeah, I have to say for this specific record, when I wanted to do an update, I have to know the ID, and then I'm going to change that to 88. I'm going to execute that. Okay, let's see, I think it did execute. And let's see what happens if I call this one. No, I didn't execute it just now. Let's just try again. So I'm going to say here, execute. Okay, it says bad request. Okay, so what did I do wrong here? Okay, so let's just get it again. Okay, so what I'm now demonstrating to you is how one can now go and manipulate this information. Okay, so there we see again that is my ID. Okay, so let's see what else can I do. Post. Okay, so I'm going to say try it out. Okay, so let's see what I'm going to change something there again, 88. Execute. Okay, so it's posted it and it's changed it. So there you can see it's actually updated that to 88. And then if I go and get it again, get, and you can see there that it is now created a new one for 88. Right, so that's basically interacting with your services. If you want to delete, here's a put or delete. Let's, for example, we can delete. So I want to say, let's try it out. I want to delete one. I want to delete one of those that exist there. I'm going to delete. It's going to say, yes, it deleted it. And I can go back and I can say, okay, well, I'm going to get it again. Execute. And then that was gone. That one was gone. It's just this one left. Right, so that is then me interacting with my API that I created, I'm testing it, and I'm making sure that it works. And when everything works, now you can expose it to a client computer or client code, and people can now invoke these endpoints in code, and you know that your endpoint works without writing the client application. Right, so that is all from my side. So please go and implement this week. Make sure you can do it, and then we will take this further next week. Okay. Hi, good afternoon, distance students and any other students that are also interested in this topic. I'm going to do some background on security. In the second part of project 2, in the API development, we are going to be adding security to your project. And I just want to give you a bit of background before we actually do the actual implementation of the project. Right, so when you look at your API basically consists out of a number of endpoints. Each of them, as you can see that I'm looking now here at 3 different endpoints, each of them that return something specific. And these endpoints are then very vulnerable. And Gartner estimates that by this year, it will be the most frequently attacked vector that is resulting in massive data breaches for organizations. So securing the API is extremely important. Many things can go wrong on this level. We can have denial of service attacks. We can intercept the actual messages, and we can manipulate them, man in the middle of attacks, SQL injection attacks. There are many types of attacks, and the main problems come from not implementing proper security and not implementing proper coding practices. That's also the other problem that we have to make sure it doesn't occur. So for our purposes, we are not going to look at all the things that one can do, but we are going to look at strong authentication and authorization, especially with public APIs. This is a big problem. So, if you don't enforce this type of thing in your application, you can have real issues in your with your security. And these things then provide an entry point to your database, so obviously you link through to the application and then through the database, and one must make sure that you obviously need layers of security. The database needs its own layer of security, but it's very important that somebody doesn't get past the API so that they can then penetrate the network further and then actually access the database. So security is always a layered approach. We start from the outside with a firewall. We have many types of hardware mechanisms that support us, but then application level security is also very important. All right, so let's think about what we are busy with. We are busy with HTTP. Inside HTTP, there is a general framework that does authentication and access control for us. So it's already there. It's actually just built into the way in which the HTTP commands are sent up and down, the requests and the responses. So I'm just going to quickly review that. And then we also have HTTPS, which is then, a secure connection that is encrypted that ensures that nobody can read a message while it is in transit. Right, so basic authentication, is normally that little first point, that number 1, that you see that pops up, and I think many people have seen that happen when they are logging onto a system. You see that happen. And secondly, digest authentication is then the second screen will look like that. You can see Windows security there, and it's very often also something like that. And these things then can be configured on the web server. But when security is configured on the web server, it is very platform dependent. In other words, you have to be somebody with a Windows credential if you want to then access content. Now, on the public internet, it is not always the case that one has access to Windows credentials or whatever credentials it is based on a platform. And so we very often would like to take security out of the platform, in other words, out of Windows, and we want to implement it on the application layer. Now, on the application layer, we have a software that will then sort of manage security, and very often we then, have things like tokens that are in JSON or XML. So those things are configured out of the platform to give us the option of connecting distributed systems together with security. So basic authentication is an internet standard that is supported by all the browsers. So essentially you can see what happens in this diagram. I say I want to get something, but this is a resource that is protected. And then it will tell me, you know what, I need you to actually authenticate. So then I'm going to support the second get command with my credential. It will then check the credential, and if everything is fine, it will send back the resource. The main problem here is that in this basic authentication, that everything has been sent in clear text, so your credentials are open, and everybody can see it. And this is basically, like I say, your Windows credentials, so this is Windows based. And so it's not really something that we can do, while we are on a public internet space. Yeah, and so the disadvantages of this is credentials are sent as plain text with every single request. They are sent up and down. And also there's no logout, there's just sending credentials, and how do you log out? How do you stop this? It's not that clear. And then other things could happen, like cross-site request forgery and other exploits that could be taking place. Digest authentication is now at the next level, which is now a little bit more advanced. And you're authenticating your credentials against something like an Active Directory, and you need something like the web server IIS. So what do we see? We say, okay, well, I want to get a resource. And so what does the web server say? Well, it's been configured to say that a certain resource is now protected, and it's going to return something to say, well, you have to now authenticate, but I'm going to send you a ream, a nonce, and then some other information. So in other words, it's sending me some unique stuff, so always remember that whenever one creates a session that is unique to that specific interaction, there's always this unique information that is then created. For example, the nonce is generally a number that is auto-generated of some kind, a random number, and it is unique for that specific point in time. And this number is then fed into something that will be returned so that nobody can spoof it. If I just take somebody's credential, I can then, just hash it and I can use it. But if somebody now adds a nonce to it, some random information, and they then hash it, then it's very difficult to try to spoof that or impersonate it, because that random information makes it more unique. So yeah, that's why we send back a nonce. Now, nonce is actually something, it means number used only once. That's what the nonce means. So basically you can see, well, I'm sending you some stuff, and this stuff you must please use now to create some secure information for me. So now I'm going to say, okay, well, on this side, I'm going to take my credential, and I'm actually going to take my credential and I'm going to actually combine it with a nonce and the ream and all of that stuff. And I'm going to send you something now. And you can see there is a lot of information that I'm going to send you. And you now have the nonce, and you then can say, yes, you are the right person. I've got your credential. I can see you were the person who got the nonce, and I will then verify you. Yeah, so you can see this is a much better way of doing it. But it's again, we are linked to Windows, we are linked to the platform. It's not a very free and open way of doing this, but this is how general HTTP security has always worked. And then we need to create a link, a point-to-point encrypted link between, the client and the server. And we do this with HTTPS, which is transport security. So in transport security, the server has a certificate, and this certificate is now used to create a secure link between the client and the server. All information is encrypted. Now, all public APIs should be encrypted. If you find a public API on the internet that you want to use and it's not been encrypted, you should be very careful. The reason why we need it to be encrypted is because then it is basically, there's an assurance that it is who it says it is. If you, for example, go to Absa as a bank or any other larger company, you'll see that they're, when you do certain things like logging into a system, it's always encrypted. And that tells you, okay, when I connect with my browser to you and there's no error that occurs, you have been authenticated based on your public, certificate. Yeah, so transport security is extremely important, and it is just there by default for public APIs. So what we need to do is we can say, okay, well, I encrypt, you can see I encrypt the connection, and over that, I need to now build something like authentication, authorization, so that when I send a secure message, in other words, my message is not open, it will be encrypted, but when it arrives on that side, I now will authenticate the user, and I'm going to then make sure that they only get access to what they're supposed to be getting access to by implementing authorization. Okay, so if I, for example, did not do these things and my messages were running in clear text, these are the types of errors that could happen. So, you could be sending a GET for resources. Now, if this is intercepted, it's not encrypted and it's open, your GET can be changed to a delete, and this could be really detrimental to your application if you delete all your resources. Your GET command, again, on this side, can actually now be getting the resources that it's not supposed to. In other words, somebody may know, okay, well, you're not supposed to get resources, but I know that in the background, there's this evil resources, which could be some financial report, and I actually am going to get it from some other site. I'm going to manipulate this whole thing, and then I can actually manipulate the command and get to some totally different place. If you want to put, you can change it again into delete. If you want to post, you can see here is a body of information that you can replace by some other body information, even if it is protected. You can just replace it just like that. So you can now send out a post and it will change. You can see we've changed the length. It's 100, there's at 120. So we've changed everything properly. And now this content, even though it's been protected, can still be used, and because this is not a protected call that is being made. You can see also here we are changing a location that we are sending through for somebody to use. And in this case here, you're seeing caching control that is also being manipulated. So there's many ways of changing your, calls, your HTTP messages and manipulating them if you're not doing much about security. And obviously, if this was encrypted, nobody would be able to do anything about it. So that's why SSL is such an important protocol to apply. So what I'm now going to show you is a REST cheat sheet. It's a general list of sort of, things that we should consider when we are actually implementing security. And this is a list of things that in general should be there. And you can see it comes from OWASP, that is the Open Web Application Security Environment. They are a group of, it's an organization that you can look at, and they always, have a list of, what is it that we must be careful of in the web application environment, and what should we be doing. So these are very important resources to look at in general for security for web applications. Okay, so first of all, what they say is you must have HTTP endpoints. That's just a given. And secondly, okay, and then and that will actually protect your credentials. Anything that you are sending up and down, it will be protected. And then they also say that if you want to go further, you should have client certificates. Now normally a web server will have a certificate to prove that it is who it says it is. But here they say even clients that are making the call should also have certificates. So both the client and the server should have certificates to ensure that both are actually who they say they are. And so that is a very important, HTTPS is then extremely important. That's where we start. So that's in place, and the rest will then be built over that. So encryption and integrity of messages is then assured. Okay, secondly, that non-public REST services must perform access control at each API endpoint. In other words, every single endpoint has to have access control, and it should be done locally by the REST endpoints. Now, there's a whole approach today that to say it's called zero trust architectures. So there's zero trust in the environment. So we assume that at any point, compromises can happen. And so every actual endpoint needs to have that own security. So you can't, for example, say, well, at the perimeter of the application, you will be authenticated and authorized once, and then from there on, you'll be just let through to do everything you'd like to do, because that could cause lots of problems in terms of security. So we say, no, that's not allowed, because, there could be many things that can go wrong. You may not have specific access for that specific service. So every service, every API endpoint will have its own security that it's implementing. Yeah, and then authentication should actually be centralized in some identity provider. So in other words, a large company with many departments will have one place where you authenticate, and from there you will be given a token, and you can then move through the whole environment. You can think about it. When you come to the university, you're given a student card. And this student card is a long-lived token. It will be there for many years until you finish. And so this token is something you carry with you, and it will let you in through the gate, in through the library, wherever you go, through some gates. So this is how it will work. There's one point where you authenticate, you get the card, and from there on, you can go and actually get access to many places based on the actual privileges that have been assigned to you that is located on the token. So we are looking in this course specifically at how to implement web tokens, JSON web tokens, JWT, as the way of implementing authorization. So basically in a web token, there's a set of claims about you, who issued this, how long will it be, and what is inside the token. You could have like claims, so you could say, okay, what can you do with this token? What type of thing can you access with a token? So there are many things, and it's then the token has then been hashed to make sure that it cannot be changed by anybody. So it's signed and encoded, but it's not encrypted. So it's open. You can, it's not an encrypted thing. So remember that there's a difference between encryption and hashing. So when you encrypt something, it's unreadable. It's been totally scrambled, and then you can decrypt it. Okay, and the reason why we do encryption is so that nobody can see it. A token is signed because we want to make sure nobody will ever change it, but you can read it. And you can never dehash something. Hashing is a one-way function. So when you've hashed something, it stays hashed. You can't reverse that process. So yeah, we hash the token so that we can still know what it is, but we know that nothing has changed on it. Okay, so then we have the concept of API keys. API key is then something that is issued when I access an API as a developer. I will get a key to say, yes, you are allowed to call me. So in every request, the API key will be placed inside the HTTP header. And when the call is made to the other side, the API key will first be checked. So that's why we can say that denial of service attacks will be limited. So in other words, every single call made to an endpoint and a service will first be checked for a valid API key. So developers will look after their keys, and people in general can't just then launch attacks against the service because the API keys will not be there and that they will not be valid. Okay, and then all requests that come in must be checked against a whitelist. In other words, I could say that in my organization, I will only allow you to get customers and to delete customers, only those two endpoints. So any other calls that are made to me, like to delete a customer, I just ignore, so I'll just reject them with an application firewall. Never trust input parameters. And this is a general thing for development that we know is applicable. Every single text field or whatever it is that you are using on a web application page must be checked for validation. And this is the same for the API. So all the fields that are passed into an endpoint must first be checked that they are valid before any application execution starts, so that there are no problems and that you are not being compromised through the input parameters. So typically hackers will sit, and they will then just send requests to an API all the time, playing around with parameters to see what can I break, so they'll be changing the command, they'll be sending the parameters all the time, and then see, okay, let's just see how this thing behaves. When will it break? When it breaks, what sort of errors is it going to give me? what will I find out of those errors? What will I be able to do with it? So it's a slow process of sort of, diving deeper and deeper into a system to see what can you get. If the system is resilient, you will not get much, and that's important, and that's what we should focus on. Okay, so yeah, and then management endpoints that people manage an API with should be more secure with multi-factor type of authentication. Right, so when you respond with error messages, also, be careful what you tell others. You never respond with a horrible long, full error message with all your application errors in, because from that message, hackers can get a lot of information about what is going on in your application. So you don't want to do that. Give a proper error message that's just to the point and that will, not expose too much about your application. You need audit logs all the time for anything you do, because that's the only thing you can fall back on when things go wrong later on, and to understand what happened, who hacked into my system, and what did they do. Audit logs are very boring initially, but when you've been hacked once, or you have a problem and you can't find who did something, then you start realizing how important audit logs are. So they are very important. Yeah, and then you must be careful that you don't have any things in your URL, like your API keys, password, tokens, or anything like that, because those things will sit in logs, and then they sit there and everybody can look at them. Yeah, and then when designing your APIs, don't use 200 and 404 only. Try to get to more detailed type of response codes. There are 70 of them that will give a better and a more meaningful response to the party on the other side. Okay, so very important for us is session management and authentication. Okay, so when we are doing session management and authentication, we have options to do API keys. Then we have something called OpenID, OAuth, and then SAML, and I'm not going to really discuss SAML and session state. Now, the API key I've already discussed. You can see, for example, that you can make an API key like either gold or silver or platinum. And, somebody with a platinum level can access all the services. Somebody with gold can less, and somebody with silver less. It also depends what they are paying. And so basically an API key is something like that. And what you do is there is an option X API key value pair in the header. You just put that into the header. On the other side, it will be checked. And that is then how you can, secure your application with an API key. So nobody can call you without that key. So OpenID is then an authentication type of environment where there's an identity provider like Google or Facebook. And then OAuth is where we actually do a authorization process through also some third party that can help us with that. And I'll show you how that works. So these are the best practices. So ideally in your environment, this is the type of sort of situation that you should implement. So yeah, so let me just look at OAuth later, and then we can see what it does in a diagram. And then generally in terms of session state. So session state is the state you maintain between the client and the server, where one of the two, they remember what the other one is doing. So let's think about, I'm going to buy a few products. I'm going to order a book and a pen and something else, and as I go through my, list of products and I select them, the server has to remember this. The server has to remember, okay, that I'm doing all of this. And now if the server is managing millions of clients at the same time, it could be massive performance issues for the server. And it's also difficult in terms of security. So our approach is that API endpoints should maintain stateless session management. So the server should not maintain state. This is just a general principle we always remember. It's not always possible to do it, but that's what we aim for. And so basically everything about a session must be held at the client. So basically what we do is we create some session token of some kind, and we send the session token to the client. And when they return a request again to us, they send it with the request, and all the session information is in that message then. So essentially that is how we make it stateless, okay? And so we have an API token and we have a session token. and that will then be the interaction. So the session is moving up and down between the two all the time. It's been stored at the client, but it's not stored at the server. The server just reads it and uses it. Therefore, the server has been freed from a lot of issues in terms of storing that type of information. But again, I say this is the ideal situation. It doesn't always work like this. Okay, so let's see what OAuth does. So when we look at OAuth, we can say, okay, there is a resource server here where resources are kept, protected resources. Let's say there's an API of some kind that you can access. And then there is somebody who owns it. Okay, so they manage and own that resource. So, first of all, what would happen is that I would say, as a client application, I would say, okay, I want to the owner of the resources, I want to access your resource. And then it will say, okay, well, if you want to access it, you can, but I'm going to send you back, but you must first get a token. And now here is an API authorization server. The authorization server knows exactly who can access what. The authorization server has got permissions per user. And so this is basically where the decision will be made. So like an access control decision. Okay, so now it will say, okay, well, I've granted you this request, you can, and it's going to say, okay, well, here is I have a grant here, and the authorization server here is going to then create an access token for me. The access token will be sent back. The access token is now going to be used to access the resource. The resource server will say, okay, yeah, you've got the token. It's still applicable. You may access the resource. Yeah, so basically what you can see here is there's an interplay between the resource owner and the authorization server. That's in other words a third party. You can see there's an environment that supports this whole access control process. OpenID is also very common and familiar. We all are familiar with this, and it's a very similar type of thing. So in OpenID, it's sort of the foundation of everything where, first of all, you do authentication, then you do authorization. But let's say, for example, I'm a resource owner, and I basically I want to watch some movie. Okay, so there's some movie that you want to watch. And so basically what will happen is I'll say, okay, I want to watch a movie. Okay, so there's a movie request. And so then a little thing will pop up on the screen. Will say, well, do you want to authenticate with Gmail, with Facebook, with LinkedIn, whatever it is that you want to authenticate with, sorry. Okay, so then it will say, okay, well, let you choose Facebook. So then it's going to go to Facebook and say, okay, well, here is somebody that wants to authorize through you, Facebook. And then Facebook will now, you'll see that third one, return a Facebook page to this person over here. And then this resource, access will be granted if you can actually authenticate properly. So you'll authenticate. And so in the background, what will Facebook do? After you've authenticated successfully, it will send a token here to say, yes, this person is a Facebook account user. Just remember, it's nothing more than that. It's just that you are on Facebook, you've authenticated, and now the movie will be shown to you because you have a Facebook account. Now, this is a very weak way of doing authentication, but if in this case you have a better authorization server than Facebook, you have a full-blown corporate authentication server that is very trustworthy, then obviously this would be a type of authentication of much higher assurance. And then in your token that you retrieve, it will be basically something like this. And all that it says in this ID token is that, yes, your email has been verified and this is who you are. And that's essentially all. So it just says, yes, you've been verified. Okay, so that's my background. So this week we are going to be implementing API security, where we have a client application calling our API. And what we were basically going to be saying is that, first of all, I would make a call to say I would like to, authenticate. So you'll see there is a call that I make to say I want to authenticate. This is my username and password. So I'm going to authenticate. I send it to API endpoint that is just there to authenticate. The Authenticate API will go and verify my credentials and generate a token, and the token will be returned. So now the client application has got a token for the user. So that's for a specific user. Okay, and then when I've got this now I can start making calls to say, I want to get all users. And what I now do is I add my token. You can see there is something called bearer that we'll make use of. So we add the token, it is passed back. And so now the user's endpoint is going to be invoked. Well, before that, actually, before that happens, you're going to first of all do a check to see, okay, well, is it a valid token? You're going to be looking at whether it's been expired or whether their signature is not right, but you'll check that. And if everything is fine, you will then get a user list. So this will happen for every single endpoint that we have. So initially there's an authentication that happens, a token is returned, and then after that, for all requests for all resources, this process will be repeating. So basically, if you don't have your token, you can't access a resource. This token could then have a certain life. It could be living for 1 hour or something, and then after that, the token will be not be usable. So that's basically what we will be implementing in our project.
And then taking you through this relatively quickly, hopefully. So welcome everybody. Today we are going to be starting with an introduction to the cloud. It is quite a bit of getting used to and a lot of concepts that I'm probably going to be chucking at you today. So what I've done is I've created quite a few different recordings that have been embedded inside of the PowerPoint presentation and will also then be included on Efundi that you can then go through as you're busy developing your project and kind of follow alongside and make sure that you're kind of working the way that we're expecting you to in the cloud. Now, I'm just going to add, as part of that, I'm not going to take you through the videos during this class because otherwise you're going to have to go rewatch the recording, rewatch how I've done everything, and then go rewatch the videos when you're working on your project. So I'm going to give you some detail while we're looking at the slides that have the different recordings on them, and I'm going to walk you through, verbally what some of the things are that you need to consider and take a look out for. So let's jump right in and move on to the next slide. So something we do every week so far is we take a look at the brief recap, pretty much as our stand-up. So by now, I see a lot of you have started coming right with putting the student number and your name in the login screen if you're logging in as guest, so we can see who you are. Thank you very much for that. It's looking a lot better. Then by now, project 1 should be submitted and you should have started on project 2, at least just have opened the brief and started looking at some of the things that you need to do there. It would have been great if you'd started some training. If you haven't started some training yet, I think you're going to maybe want to get started on that because there is a lot that you're going to need to consider while busy on this project. Then something you also would have wanted to do is actually touch base with last week's recording and make sure that you understand what Prof. Coetzee showed us with being able to set up an API and what an API is and what it does and what the controllers are and what the different methods are that we use and so on and so forth. So from that, it would have been a good idea to have started creating an API based off of a local version of the database. Now, what we'll be doing is after today, you'll be expected to actually take a database and put it into the Azure cloud, or the pretty much the portal where I'm going to show you now how to interact with Azure. So you'll have to create a SQL database and a SQL server there and actually host the database there that is then connected to your API. Now, in terms of project 2, we're going to expect you to make sure that your work is source controlled. If your work isn't source controlled, then we can't see what you've done, which means that we can't give you marks on your work, which means you're going to have quite a significant gap in your rubric. Then you need to make sure that you've actually updated your GitHub project, make sure that the tasks that you need to put down for this project has now been defined on your GitHub project. We saw that with the project 1 submissions, a lot of you pretty much just did the bare minimum. You didn't include any tasks. You kind of just went, with the high level stuff. There wasn't really much thought that went into the rest of your planning. And I'd like to caution you against that because you're going to get to a point in the semester where you're going to feel like you're overwhelmed with work and you're not going to really know how to balance everything, and it's going to be difficult because if you'd broken everything down and kind of planned for it retrospectively the way that we've now expected you to do, then it wouldn't be as overwhelming as it's going to seem when you get to that point. So project 1 is in, we're busy marking. I would very much urge you to start considering how you're going to update your project to reflect the tasks so that you don't run into problems later on. Because if you run into problems later on and you tell us that we've given you too much work, we are going to tell you that it's because you planned incorrectly and not because you got too much work. So please be cognizant of that. Make sure that it doesn't affect your timelines and your deadlines and your anxiety levels. It is very important that you get the planning right. So take a look at that if you haven't done so already and you haven't looked at things on a task level. You've got all the projects, so revise your plan and see if you're still on track. Then we're going to expect you to host your API and your database on cloud. GitHub is not what we mean. We actually mean on Azure. And that's also to make sure that you avoid any marked deductions there. Then please ensure that your repository is kept private so that your friends don't steal your code. I know that was a big concern that a lot of people had. As long as you share your private repository with the people on the project brief, everything is good. Just make sure that you don't keep it public for everybody to see. Then once again, training should be underway. Make sure that you add your reference list to your GitHub repo for the second project. And then something that I posted on the LinkedIn group earlier this week, I think it could have been yesterday or the day before, is the meetup that we have this afternoon with regards to UiPath Studio. So there's a new product that has been released. We're going to be talking about it in the meetup. So if you kind of want to get a feel for what UiPath is about, you're more than welcome to join. If you have experience with UiPath and this is something that is going to excite you, then feel free to join. The link is in the LinkedIn group. Then just another important point, there will be no extension deadlines or extension to deadlines for the different projects. All right, so I've added quite a few different YouTube videos and normal videos and recordings and that kind of stuff into this presentation, so it is quite bulky. And I am going to expect you to download it after class and go through it yourself. But essentially, if we start off with what the cloud is, it is a very controversial discussion when you look at it from different perspectives, because there are different things that you can do with the cloud. And essentially what you're looking to do, or what you're looking to understand, is that it is actually just somebody else's much larger computer that you're storing all of your stuff on. And if you use it incorrectly, it can actually be very unsafe to use. So with that in mind, there's a lot of elements that you'll need to take into consideration to make sure that your project remains secure and that your resources and everything are pretty much hosted the way that they should be. And a lot of that has to do with the way that we've been talking about the gitignore files and so on and so forth. Now, when we talk about cloud, we're talking about cloud computing and we're hosting things. If you talk about cloud in general, there's a lot more that can be taken into consideration, and I'll discuss that in a bit. So first, let's understand who are the main players that we have in South Africa in the cloud computing space. Now, cloud computing is essentially we're restoring our resources, restoring our APIs, restoring our applications, our servers, our virtual machines, those kinds of things. Now, there's a few, Microsoft, Google, those, and Amazon. Those are generally the three biggest competitors that you'll find in any country, really. Depending on the restrictions that have been put into place, you might not find Google in China because of some of the recent debacle that has gone on there. So generally, in most countries, you'd find those three as the big three competitors. Then IBM Cloud is also making tracks. SAP Cloud Platform and Huawei Cloud are also pretty big competitors. SAP is very specialized, so anything SAP related will then go onto the SAP Cloud, whereas the Huawei Cloud, IBM Cloud, Google Cloud, AWS, and Microsoft Azure allow you to pretty much put resources on there based on an agnostic approach. So you could put C# code on either of those platforms. You could put Node.js on those platforms, Python. There's a bunch of stuff that you could put there. Now, with that being said, there are certain stacks that work better with certain languages. So for example, Google Cloud Platform works really well with Java. It works really well with Python and sometimes even Node.js. It's a little bit more tricky to get Node.js on there. IBM Cloud is very much, in favor of Node.js. So if you do a quick Google search and you look for the IBM Nation Africa, I think it's free training that you can do on the IBM Cloud. A lot of the apps and the APIs and those kinds of things that you write is actually in Node.js. So, the platform works really well with Node.js. There's a lot of standards and settings and config that you can put together to kind of adhere to that. And then AWS also kind of suits, many different stacks. It works really well with Python as well. And then Microsoft Azure also, Python, C#, those are really cool to work with there. Huawei Cloud is a bit of a mixed place at the moment. You can, in theory, kind of keep whatever you want in there, but everything's a bit of a challenge. So we're not going to look at that just yet. Now, if we look at what goes onto the cloud, the answer to that is just about everything. If you have a database, you can put that onto the cloud. If you have an application, you can put that onto the cloud, whether it's web application, whether it's a progressive web app, whether it's a mobile app, any app that you can think of, you can pretty much host on the cloud, same as with an API. There's usually a storage mechanism, so you've got things like blob storage or storage files or storage folders and those kinds of things that you can actually use to keep all your collateral safe. And that collateral is usually interacted with through your applications or your APIs. There's a bunch of different challenges and things that need to be considered when you're actually implementing those, and we'll chat about that in a bit. And then servers, virtual machines, those kinds of things can also be hosted in the cloud. Now you'll see here at the bottom, there's a different kind of concatenation of things that you can put together. So you can have a private cloud, a public cloud, or even a hybrid cloud. Now, the reason for this is because private clouds are usually set up for organizations that don't want their data to be accessed anywhere outside of their organization. So financial institutions, medical institutions, those kinds of places usually actually use a private cloud. Public clouds are some things that you and I would use. The Northwest University is part of the public cloud of the Azure version. So there's a few things we can look at. And then what you can also do is use a hybrid cloud model where you actually use things like B2C, where you actually connect, and I'll explain what B2C is now, but you can actually have two clouds living next to one another and actually connect the two together. So B2C, if I'm not mistaken, stands for business to client. And essentially what that means is you can have two different tenants where you've got two different sets of users and active directories and those kinds of things, which is where users are stored and all the information is stored. And you can create a link between the two, which is then referred to as B2C. So you can auth to the one cloud, and then through the auth that you've done to the one cloud, actually auth to the other cloud as well. And that's generally how hybrid clouds work. So what would happen is if we had a large organization, let's say it's a financial organization that has a private cloud, and we've created an application for them that is front-facing, or they're utilizing one of our APIs would be stored on a public cloud. And what we would do is implement B2C to auth into our tenants so that we can auth into their tenants and pull the information that they need. Now, there are many vulnerabilities that can come in like that, which is why it's not something that is actually presented quite often, but it is a possibility, and people do sometimes do things like that. Then there are multiple different cloud comparisons. So if you have something like an app service on Azure, now an app service is going to be where you actually host your API or your application. Now, if you have one of those on Azure, you'll be able to find the equivalent on AWS and Google Cloud Platform as well. So the resources between the different platforms pretty much exist all over the place. It's just the naming that is different. So you'll see here, for example, the SQL databases. You'll have Amazon RDS, which then is a SQL database, which is then a Cloud SQL database on Google Cloud Platform. You can have NoSQL databases. You can have analytics. There's some automation stuff that works there. So if you need to see, what the equivalent is on a different platform, this is a really nice place to see it. Now, I did say to you that there are different ways that you can actually implement a cloud strategy. So you can have cloud computing, which is what we're talking about here, and you can have just general cloud storage. So if you look at something like Dropbox or OneDrive or SharePoint or anything like that, even Samsung Cloud, iCloud, those kinds of things, it's a place for you to actually upload your media. Now, you're not actually running, intensive applications off of it, but it is a place to store your media. That is also referred to as a cloud platform, but it's not a cloud computing platform. So that's where the two differences come in. So you'll see that the first video on the first slide refers to cloud computing and explains to you about pictures of Frank, and if Frank is happy, you're happy. And I'm going to leave that as a teaser so that you can go look at the video and understand for yourself. Now, essentially what they're referring to there is a cloud storage mechanism that can be used in the context of cloud computing. So go take a look at that, and if you have any questions, then I'm here to answer them. Now, the next question is, how do we actually interact with the cloud? And the thing is, or the answer to that is whatever ways is convenient for you. And this is something that definitely needs to be taken into account when you're designing and developing a solution. So if you're developing a solution that is hosted in cloud for deliveries, you would like the person who is in the car actually delivering the products to actually use their mobile phone. It doesn't make sense for them to use a desktop because they don't have access to a desktop while they're driving around. So the convenience option there would be to either use a tablet or a phone. Now, what would happen is through the tablet or the phone, you'd actually access everything that is running in the backend. So you'd have almost like an interface, which in this case would be your application, and your application would make use of the rest of the stack. Now, likewise, you could have a different portion of the same solution where we're looking at the logistics company, the actual warehouse where things are now being shipped to the trucks. And there you might actually use a desktop application or laptop application to actually interact with the cloud and actually get the same data and plan the routes that the drivers would need then to be able to deliver the goods. So it really just depends on what is the most convenient option for the use case that you're working on. And it is a design aspect that needs to be taken into consideration. Okay, then what we're going to be doing for this project or for the rest of the semester really is we're going to be looking at Azure. So we've now explained to you that there are multiple different cloud providers that exist. We've explained that there are different or the same resources with different names across the different platforms. And because we've got licensing available for students in the Microsoft environment, we're going to be using Azure for the reason that everything will be consistent. If you need help, we'll be able to help you in a very consistent manner. The videos that we put together will work for you. And also it works really well with C# code. So I'll show you and you'll see as you go on with some of the videos how easy Microsoft actually make it to do something like this. And the idea behind this is if you can implement something on Azure, it is really easy to be able to implement something on Google Cloud and AWS in the same fashion, because essentially if you understand the concept and you understand the inner workings of it, you can apply it pretty much anywhere. So let's look at how Azure works. Now, essentially, when we look at Azure, the general understanding of the general consensus of Azure is that everything is grouped together somehow. It is very hierarchical. I think that's something that Microsoft does really well. They don't really put many flat structures in place, but for all intents and purposes, it works quite well. So you start off with a subscription, which is then based on a tenant. So the tenant would be the Northwest University tenant. Your subscription would be your students, your Azure students for free subscription, and you'd create resource groups inside of that subscription. Now you can create as many resource groups as your heart desires. Essentially, all you're trying to do with these resource groups is group things together. So there's different strategies that you could employ. You could use different resource groups for different environments. So for example, you could have a resource group for your dev stuff. You could have a resource group for your prod stuff. All your testing or your QA stuff can be all encapsulated into a different environment. Or what you could do is actually split out the different layers of your solution into different resource groups. So you could have an app resource groups, an app layer, you could have a data layer, and then you could have like a presentation layer or storage layer or something like that. Now, essentially, the reason you split things into different resource groups is to take security into account. You want to be able to give different people or different groups of people different access to different things. So, for example, if we're working on that financial institution example, we wouldn't necessarily want all of our developers to have access to that data because that data is coming from somewhere else, but it's okay for our developers to have access to the app. So that's kind of the way that we then manage the access. They wouldn't have access to the data resource group, but they'd have access to the app resource group. Now, inside of that resource group, you'd actually now go create some of your resources, and this would very much be dependent on your strategy. So if we're looking at this as an entire dev environment, and we're trying to understand, okay, we're going to split everything out by the different layers, then on the app side of things, we'll have a resource for the app service, we'll have a resource for the API service, so this is like a web app and your web API that you've got separately. Then on the data side of things, you'll have a SQL server and a database. You can't have a database without a SQL server. So you have to create both, and you'll see in the video how to do that. Now, bearing in mind, you'll see some funny text here at the bottom. That seems to be almost like hieroglyphics. It feels like hieroglyphics when you're putting them together. But essentially, those are examples of how you'd actually implement a naming standard. Now, you can see I've got a few different naming standards here. They're not the same. And the reason for that is because I want to show you what is possible. Now, the examples that I've put together aren't necessarily according to best practice. That is something I want you to investigate and find. I don't want you to copy the best practices that I put down or what I put down, because if project one is anything to go by, a lot of you just copied what was already done and didn't really learn anything for yourself. So this is going to be another good way for us to understand whether you actually understand what you're doing and what best practices are. So I've provided a link to what those naming best practices look like. It's not going to take you long to just read through that and use that as your starting foundation of actually naming your apps or your resources. So take a look at that, and if you have any questions about what things mean and so on, then you're more than welcome to let me know. Okay, so when you're getting started with Azure, you're actually going to have to claim your Azure account or your student account. So I've actually created a video to show you how to get started. Make sure that you sign into the portal.azure.com with your MSFed account. So that's the student365.msfed.nwu.ac.za account. If you don't know what that is, then I'm sorry about your project one, because that would have been the same account that you would have used to log in there. And if you haven't submitted your project one, then please just check some of the previous recordings to see what we refer to when we mean the MSFed account. Okay, so in this example, I've used my staff account, not my student's account, which is why it's staff 365. So just please make sure that you sign in with student 365 and that all of the auth that you do is with student 365. Staff 365 won't work for you. Okay, so I've gone through a very detailed explanation of exactly what's happening and how you can actually retrieve your credits. You don't need to put a credit card down. So please just make sure that you do this so that you don't incur any costs yourself. You'll have $100 that you can use, which is more than enough for what you need. Then what I would also suggest you doing is going through how to create a resource group. I've showed you what the naming should look like, so you can actually create a resource group. Make sure that you do it on your student's subscription. If you follow this example or this tutorial or this video, you'll see exactly how to do that quite easily. So I'm just going to skip over to where the resource group is created so that it just makes sense to you. Okay, so we've got the resource group created, and now inside of the resource group, we can actually start adding resources. Now, there's two different ways that I've explained how to create resources. The one is the SQL Server and database route, which is through the portal. And then I'm going to explain to you how to create resources from Visual Studios. Now, the SQL Server and the SQL database, I always suggest that you create it from the portal and not from SQL Server Management Studio. If you create it from SQL Server Management Studio, it puts you on a Gen 5, which is a much higher pricing tier, which is very expensive. And if you run out of credits because you're on a Gen 5, I'm sorry, that's going to be a huge challenge and a huge risk. So please make sure that you create it through the portal. Make sure that you use the free option. Follow the video, you'll see how to create the free option, or at least the much cheaper option, the basic option, and then the database you can make free. So in essence, the databases and the SQL servers by best practice I do on the portal. You'll see that there's a way that you can create it, which then ends up looking like this. You can then log into your SQL Server. Okay, let me just show you what that SQL Server looks like. Okay, so there's your SQL Server. Once it's been spun up, you can actually then go into your SQL Server Management Studio. You can sign into your server and your database, and you can use it perfectly fine. Okay, then the next thing that you're going to want to do is create an app service once you're now ready to publish from Visual Studio. So you'll work in Visual Studio on your API and later on your web app in Project 3. So you'll follow the same concept. And essentially from here, you'd actually go through the prompted areas of actually, or the prompted process of actually signing in and publishing the process, creating the different applications and so on and so forth. Now, just one thing, this project that I'm busy running here doesn't have executables or program.cs files or startup.cs files. So it actually just deploys as a web job. So what you would want to do is actually create an app service, which it will prompt you to do. So don't stress about that. It's very intuitive. It gives you next, 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 and then you just have to fill a bunch of stuff in. Be very cognizant of your naming conventions. So as you'll see here, they've got some numbers and letters happening here. Please just remove those numbers and letters and actually name it according to the standards. And then once you publish that, publish it as much of the stuff that you can publish in the South African region. Please publish it in the South African region. We have two different, what do they call them, data centers in South Africa. We've got one here in Johannesburg and we've got one in Cape Town. So they are the cheapest because they're the closest to us and there's less latency. So please, use that and see if you can publish as much of your stuff there as possible. And then it's as easy as just clicking publish and it publishes to Azure. And then you'll see that in Azure, it actually exists. So there it is. Now I see we've got 2 questions. Can I create my own small cloud? You can create your own small cloud. It's very difficult to do because if you're going to take if you're creating just a normal cloud platform to store photos and those kinds of things, so more like a cloud storage platform, it isn't that difficult to do. But if you're creating something like a cloud computing server, you actually need to put compilers in. You've got to make sure code runs, and it is quite complex, but you can actually do it. The Azure subscription is probably a good way to kind of understand what goes into cloud services before trying to create your own. Then I see Charmaine asks if we're allowed to use Visual Studio Code. You're allowed to use Visual Studio Code, but publishing to Azure is a little bit more tedious. It's not impossible, but what I'm doing is actually using it from Visual Studio because it is easier to implement and it is less buggy. Okay, then I see Deerwald is asking, can I please get an explanation about the difference between Azure Cloud and Git? Why we would still use Git instead of Azure? Okay, so Git is specifically for source control. Azure is where you host your app. So if you put your stuff in Git, it's just source control. I can't actually access your API. If you send me a URL, I'm not going to be able to run your code. I actually have to download your code from Git, set it up on my own computer, and then it'll work. Whereas with Azure, if you publish it to Azure, anybody can access that solution and actually use it. So it's a difference. It's a difference between technologies. Git is there for source control, and Azure is there to host your stuff online, so that people can interact with it, so that you can interact with it. Imagine you're trying to create a database, right? So we're working on the same project. We've got a database and we're trying to make different entries. If we've got a version of the database and I add things to my database on my local and you add things to your database on your local, our 2 databases aren't going to sync, which means that the data that we're putting in is actually redundant because we can't actually communicate with one another. So that's what the cloud and what Azure essentially removes. You can actually communicate with the same database and everything works quite nicely. Okay, so that is then from a resource perspective, how you actually create things and work with things from there. And then I've added one small extra video that I'd like you to go through, which is actually quite intuitive. It's how to connect GitHub to Visual Studio. So if you create a repository in GitHub, how do you actually get that into Visual Studio so that you can work with it and make the changes and apply the changes quite easily? I mean, by now you should know what the different commands are. So here I'll show you pretty much how to sign in with GitHub, how to clone your repository, and then how to actually implement a change. So go through that in your own time, ensure that you understand how it works, and if you don't, then please feel free to reach out to me. Okay, then I'd like to open up for any questions regarding cloud. I don't expect you to have as many questions now as you would when you start working with it, which is why when you start working with it, please, we're here to help. Please just try not ask us questions that the videos already answer. Make sure you go through the videos first before you ask those questions. Any questions? Okay, then what I'm going to do is I'm going to hand over to Prof. Coetzee, and then the questions that are coming through I'm going to answer in the chat.
Good morning, everybody. Can everybody hear me? Can you hear me?
Yes, we can hear you.
Yes,
Okay,
we can.
thank you. Right, thank you so much. Right, morning, everyone. I hope you are ready to go for this week. And thank you very much, Ms. Miller, for that presentation. So, the main thing is for you to take responsibility now for your progress. We are giving you a lot of information. It may be, like we mentioned, a bit overwhelming, but if you take it week by week and you just do the little bit that we ask you to do, you'll see that it is very manageable. It's not, we are giving you a lot of information, a lot of assistance, so it should be fine. You're right. So today what I want to continue with is this week I did provide a recording on security. I also did that in my class. And I want to continue. If you look at the project brief, you'll see that one of the points is that we want you to have your app authenticated. In other words, it's not something that you can just access, and do with it whatever you like. You have to provide credentials. So we are going to look at best practice in terms of that. So let me share my my screen with you. Oops, that is not what I wanted to share. Right, so let's start from the beginning. Okay. Okay, so are you looking at the right screen there then?
We're seeing your teams at the moment, but your presentation was up, yes.
Okay, let me just go back there. Right, can you see now?
We still, yes, there we go.
Right, everybody, so morning, and I just want to first of all start and just say, you know, let's get excited. I think we are busy with the most amazing type of work. It is really, if you think of what you can be doing in industry, this is one of the really nice types of development that one can be involved in. And you're really learning new skills that really will make a change in your life. And yeah, there may be a lot of pressure. You've got other subjects to do, but I really want you to really get excited about what it is that we are busy with and really look forward to every week and see what is it that you're going to be learning this week that really will be something new for you and that is really very interesting. You know, the IT industry changes so much. And you are going into such an interesting field. You know, there are so many opportunities, and something like the course that you are busy with is just another exposure to what you are going to be seeing in industry. And yeah, I think that's one of the nice things of our field is, you know, we want to see people that have the ability to get excited about new things and quickly teach themselves those new things, because that is what employers want. You know, anybody going into IT, this is expected. And the sooner you get into that mindset, the better, you know. So whatever, it's also like what you are doing this year, you may move into industry and within 2-3 years, things have changed again, but you must adapt to that. And that's what makes our field more interesting than many other types of fields that you go into. So what I want to talk about today is how do we secure our API? So basically what we have is our endpoints, and you can see here is our categories table that we've created in our database, and it's got a number of endpoints. So what we want to make sure is that nobody can access this like the get endpoint without having the right credentials. So in the project brief, basically you have to support authentication on your, and actually also authorization on your app, on your endpoints. And so, yeah, that's what we essentially want to do. We are going to apply JWT authentication and authorization. Now, I've already mentioned this in the video before, but there are 4 common methods of web API authentication. You can use basic HTTP, which we will not be looking at. You can use API keys, which is something that one can add, but we are not going to be doing it. But then the main best practice in industry would be OAuth or OpenID. And those are both token-based authentication types. So what we are going to be implementing is just the basic token-based authentication. But if you understand this, then, you know, OAuth and OpenID will be more, you know, viable for you to also then do. Right, so very important is when we implement security, we never build it from scratch. You know, that's something that's very important to understand, that if you decide as a developer, I'm going to just do my own thing, build my own sort of authentication and so forth, very often you can really end up with making some serious mistakes and you can be compromising your environment and it can be full of vulnerabilities. So what we do is we use best practice and tools provided because these things have been defined by, for example, Microsoft. You know, they've got like PhDs sitting there for many years, really making sure that their tools are secure. You know, many years ago, for example, Microsoft ended up in a situation where they had so many security problems. They are known for that. And so they took their developers out of, out of their normal work. And they did just then for like months, they made them do security courses, made sure that they understand security, and then put them back starting to develop tools again. And so that's how important it is to them, because it's something that really did, it was detrimental to their reputation. So yeah, so they've got tools for us that we must use. So there is something called Microsoft Identity that we are going to be using, which is a ASP.NET Core Identity. And that is something that we can use to actually maintain user logins, which you're going to be storing in your database that you've created already. And we are going to be using the entity framework and identity framework together for database operations. And so this is a default implementation. So the code that I'm going to show you today is very standard. You know, you can get it all over the place. It's nothing new or special. And I'm giving you, like before, most of the code, which you just have to go and implement. So we have a namespace, Microsoft ASP.NET Core Identity. And in this namespace, all the entity models exist. So in other words, these are the sort of classes that we can use and the data that we can use. Things like identity role, identity user, we're going to look at how we use that, and claims and roles and tokens. You know, so they've gone and thought of, okay, what are all the things that one needs for security? And they've made sure that those things have been implemented in this framework. Okay, so how do I now get this into my database? So, you know, so they've got all these models. And so I want to make use of these models and I want to store them in my database. So basically here in this case, we are going to make use of migration. So last time we used scaffolding, you know, and scaffolding, that what you saw about that is you've got a database and you are going to then create some classes. Now we are doing the reverse. So we say, okay, I have some models, but I want to put them into my database, and this is what I'm going to use the code first approach for and migrations. So basically, I'm going to take my entity models that I have, and I'm going to take these, and I'm going to use the EF Core model, and I'm going to migrate the information into the database. In other words, I'm going to create some tables in my database that will store user information, login information, passwords, and roles. And it's just a very straightforward process that I'll be doing. And then I'm going to end up with these tables. You'll see these are the tables that I'm going to get, you know, like here is ASP.NET user. So there's a user table, a role table, a login table. Now, in our application, we are not going to use all these tables, just we're going to touch on it. And this is what the database structure would look like. So here you can see, here we have users, and you can see we have the username, the email, the password hash, the security stamp, the phone numbers. All this information will be automatically generated for us. You know, so they thought about, if I have a user table, what is it that I have to put in the table? Now, this is the standard sort of automated default options that are created. But if you want to change that, obviously, you can also do that. But yeah, so there's a really nice sort of structure provided to us to be able to do authorization and authentication. Right, so what are we doing in our project? Okay, so I said we are doing token-based security. It means basically that I authenticate, and then when I authenticate, and so it checks the password to say, yes, I'm the right person, a token will be provided to me, and this token is then going to be passed to all the services that I'm going to access. All that the service will do, it will check the token. Are you, have you been authenticated? That's what the token basically would say, and then I would continue. Okay, so what I need, first of all, is I need on my server, I need some endpoints that are going to be doing authentication. And then over here, I have my endpoints that are not my normal endpoints that will be doing my normal functionality. So first of all, what I would say is, okay, I want to authenticate. So this will obviously be the authenticate endpoint. Here is my username and password. So I'm going to send this in. It will be checked. And then I'm going to generate a token and pass the token back to the client and to say, yes, 200 OK, here's your token. So now the client's got the token. And when the client now makes a request for, here we have the list endpoint, the client is actually going to add the token using what we call the bearer header type. And it's going to pass the token in. The method here, or the endpoint, is going to check it, validate the token, look at whether it's still a valid token, expiry date, and validate the signature to make sure that it has not been modified. And then it's going to say, yes, here's your stuff. So for every single request, so once you get the token, the first time when you authenticate, you get the token, and thereafter, each and every time your token will be used for all calls, and make sure that you have been authenticated properly. Your token will have a certain lifetime that it will live for 1 hour or 2 weeks or whatever you want to make it. So this is essentially what we'll be implementing. And so our endpoints that we are going to be adding will look like this. So there will be a register for a user, a register for an admin. Each of them are different then, and they will get different roles. And then we can log in. And after we've logged in, we'll get a token, and then we can go and do our we can then access our methods. Now, I'm just going to demonstrate to you how we do this inside just the normal default application. Okay, then I've talked about the bearer authentication and what does that mean? Basically, it is a way of implementing security within HTTP and the HTTP call, and it comes from the OAuth authorization framework. That's where it's been defined. And so basically you just, and you'll see when I do the actual code and the implementation, you'll see exactly what that means. And this is then what a token looks like. So when I look at my token, this is what I see. It's just, a lot of characters like that. But if you go to jwt.io, you can take a token and it will decode it for you. And that's essentially what you'll see. You will see the content of the token. This guy's called John Doe, that's him. And then you'll see, okay, this is the algorithm that I'm being using. It's a type JWT. So I'm hashing with 256. And then here's my signature to make sure this is where the checks are made so that the content will not be changed. So we know that when we hash something, we can read it. It's a clear text, but we know that it has not been changed. It's of high integrity. Right, so that is then the slides. So now let's go over to our code. Right, so what I'm going to do here is just want to move this thing to my other screen. What screen are you looking at now? Okay, I just want to.
We see the Word document.
Okay, yeah, I don't know. Let me just change it back. I wonder how am I going to change this back now?
Okay, we're seeing security guidance.
Yeah, okay, let me just think, how do I change it back now? Oh, well, let me move this thing then. Okay, so you can see that now.
Yeah.
Okay, so let me just move this thing back here. I don't know why this happens. Technology is never ending. Okay, right. So now let's have a look at this screen. And so here I have opened a project that I've already created. I'm not going to show you all the code that, step by step. I've already done some of it so that we can just do this quicker. So basically, I have a project. This project is called API Security. I've just actually enabled the default, just when you enable the default application, which is the weather forecast, class that we've implemented there, which is just returning weather forecast information. And I'm just going to demonstrate to you how I implement security on this, and you'll be able to do exactly the same for your project. So basically, first of all, if we go and look here at the packages that I've already added these packages, so you can go and I'm going to also provide you with a guidance document where you can step by step go through the document and do the same thing. But you can see what I've added here is we've added here Entity Framework Core SQL Server, which is then interacting with our database, and we have the Identity Entity Framework. We have then the Identity ASP.NET Core Identity. We have the token one tools, and then for Swagger we have the OpenIP and the Swashbuckle like we did before. So those are then the packages that you have to go and apply to your project. Right. So what I'm going to first of all look at is what files do we have to change for our implementation so that we can get this implementation to work with security. The first one that you have to change, which I'll just quickly look at, is the app settings one. Now in the app settings one, last time you remember that we actually added our connection string in here. But what we now have to add in here is we have to, in this app settings, change our settings for the token that we are going to be using. It has here valid audience. Now it's just got that link there, which is really meaningless, but essentially that will be the audience who may connect to your server. And then the valid issuer is then, who are you? And then there's a secret that is added to your token. So those are things that one has to set up to get your token to work properly. Okay, and so the next thing that I'm going to look at is now I've actually created on my solution, I've created a new folder, and all my authentication type of classes are going to be added in here. So, you know, I've just sort of layered my little project a little bit so that everything that has to do with authentication is going to be sitting in there. And the first one that I'm going to be looking at is the application context. Okay, so basically here, what's the importance about this is we want to use the identity context. Okay, so this is enabling me to connect to the identity database that I'm going to be using. And then we are going to have an application user, and you can just see this is my user inheriting from identity user. So all the you know, classes and so on available, or the methods will be available for me there. Then I think the next one that we are going to be looking at is the, let's just go through them. We have the roles. So user has a role. So we define, for this purposes of this application, you can define other rules, but we have an admin and a normal user role. I can then register somebody. So here we see a registering. You are using username, email, and password. So those are the three options we are registering with, but you can also add more. You can see there we have something called email, but we've changed it into email address. Okay, that is, and then we're going to log in, and login will have, here we see we are inheriting from authentication, and we are going to use username and password, and that's how we log in. And then, yeah, we have responses, and any response that returns will have a status and a message. Yeah, so these are then the classes that one needs for the authentication part of the application. Right, so when we've completed that part, what we are now going to be doing is we are now going to, okay, so remember that I showed you on the slides that we need to have new endpoints for authentication. So on my controllers folder, we see here that I just have my normal controllers. This is the only one I have here where I can now send out the weather forecast information. So on here, I actually now have to go and create a new you know, methods that are going to now do authentication. So I'm going to add in a new class here. And I'm going to call, it's going to be a class. I'm going to call it Authenticate Controller. And I'm going to add the following code to it. So this code is, again, what I provide to you. And like I say, it's very standard. You know, it's very sort of generic. And so we are just going to copy this in here. Okay, so essentially what this code is going to be doing for us, it is going to, see, I've got there. It's going to then, you can see I have a number of namespaces that I'm using there. But basically what I'm looking at here is here I'm creating a namespace, JWT Authentication, which is a controller. And I'm going to then say, right, I'm going to implement a login function. You can see that is login that I defined, and I'm going to then have a register, which is the register there, and I'm going to have a register admin. So those are the basic, like I said, those are the three endpoints that we need to implement here. So now you have your authentication controllers and your normal one that you would have. So you're separating, you know, your security, which is very important, from your functionality. Okay, so now we are going to be looking at the startup where we are registering whatever we need. And basically in the startup, there are two main things that we do. We configure our application when it starts, or we configure the services, which is very often optional, but you know, it's something that we are going to be doing in this case. So I'm going to now replace in the startup, I'm going to replace this code with this code. And so what are we adding in the startup? So in the startup, what are we adding is when we configure our services, we normally would just say service, we're adding a controller in, but what we are now doing is we are now adding in our database that we are going to be using, and we are going to be adding in our identity that we are going to be working with and authentication. So those things have been enabled, and we are also adding in our token that we are going to be using. So those are then the three things that we add in there. And you can also see then in the configure part, we are using authentication and authorization. Right, so that is essentially what you do there. Okay, and so now we are done with most of our sort of standard things that we need to add. And so now we have to say, okay, I want to protect my weather forecast, sorry, not there in the controller. I want to protect my method or my endpoint that is going to be invoked. And so what we essentially do is we have an attribute that we decorated with that is going to go there. And I can just add there authorize. Okay, so I'm just going to put in there authorize and then okay, so I've just added that in there, and this will then, if you do that, so what essentially will happen is when your endpoints are invoked, what you are saying is then that when this weather forecast controller is going to be called, it has to be authorized. Okay, so that means it has to be authenticated. So you just have to authenticate it, and if you are authenticated, then everything would go okay, and you will be able to access the actual method. Now, if you want to add authorization, now authorization is slightly different. It's the same thing, but if I want to say no, but not only must you be authenticated, you must also be in a certain role, you are going to be adding that. So you're going to say, okay, authorize, but I want to make sure that the role is an admin role, and that depends on the roles that you've done. Okay, so now you've got an admin role that, so in other words, nobody can access, and this is now per, you can see this is here per, you know, you're going to have to do this on each and every of the endpoints that you created. In this case, we only have one endpoint in this code, but if you want to, you know, on every single endpoint, you have to decorate it with that specific attribute. Right, so now we've created our code. Our code is ready to be used. We'll only have to also add the Swagger in like we did before. Okay, so now the next step is actually to look at our database. Okay, now we've got, you know, all the code in, but we need the tables to be you know, creating this sort of thing here. And so if I should look at my database, I'm going to move my database there. You can see here is my database. You know, I've got my 3 tables, and there's no security information in these tables at this point in time. Okay, so what we now do is we are now going to, we have already added all the packages in. So we are going to go down here to the package manager, and we are now going to say, okay, we run this command. So I'm going to do a migration initial. So, you know, it's going to take, you know, so what is it doing? It's looking at the models that are in my code, and it's going to migrate or create a migration script to be able to create the databases that I need. Okay, and that is not what I want to see. So what could the problem be? Rules failed.
Maybe try right click on the app API security and then clean it and try build it and see if it gives you the error.
Okay, let's just do that.
Okay, and if you go to the error list, it should show you what failed.
Okay,
Oh,
okay, something with startup. So where do we go now? Let me just stop that.
So if we go to error list here at the bottom where the output is, yeah,
Okay.
and then double click on that, it should take you to yes. If you just control, yeah, you just add the using. Yeah, there we go.
Okay, that was missing. Thank you. Okay, so let's do that again. Okay, so that's fine, thanks. Okay then. Right, so now what we see, what's happened is when you do this, it's taken whatever in your code and it's now written this migration file, okay? And so what you see here, and you can also, like here it's going to create a number of tables. So it hasn't done the database yet. It is now creating, it's going to give it's sort of a script that will create the database. And here you can see there will be a roles table and that will be the fields there. And there's a users table. And you'll see now this comes obviously from, the namespaces that we've pulled in and so on. And so here we see, okay, these are all the fields that will go into your users table, which is like much more than what we'll be using. And all the different tables are sort of here by default. You don't have to do anything. So this script has been created for you. And so all that you now have to do is, and you can change the database names if you want to, you can change the fields, and you can make some changes as you wish there. But now we are going to just say update database. And so it runs the script. And now when I go to my SQL database, so let's just see if so refresh it. And now you see that it's actually now taken your database and it's now created all those tables for you that you now can use for your security. So it's actually gone and done that. It's very easy to do that actually. So now now you've got everything ready. Your code is done. Your database is there. You've got your controllers, and so you can now. Well, all that we still have to do is like we did before. Is we now have to add Swagger. And so basically in Swagger, we just have to go and add in some assemblies there. So in the startup, and this is exactly what we did before. In the startup, we need to have Open API and API models. And then in the over here, when after add controllers there, we need to now add Swagger in there. So I'm going to add this bit. Okay, so we've added that in there. So you can now see that you've added Swagger in, but now Swagger, you need to actually be able to enable it with your token. And you can see there we are using Bearer as a security scheme. So it's not just adding Swagger, but it's also adding Swagger in with your actual security. And then we have to the end of the startup, again, like we did before, we have to add over here. We have to add those options on Swagger there. Okay, so that's what we have to add here. And then in the launch settings file, you have to add in Swagger. So we replace the code like we did before. Okay, and it's called API security. So we need to make the same thing here. Right, so we've got API security, and then I think everything should now be ready to go. So let's see what happens. Okay, so what is it there? Okay, so let's see where is, so what do you suggest is wrong now? Okay, wait, there it is. It's on my screen. I have to move it that way.
Okay, so we're still seeing your Visual Studios.
Yeah. Okay, I'm just trying to move the screen for you. Okay, so it's now executed. So what we now see is we see our weather forecast controller that is exposing that one endpoint, and we now see that we can now log in, register, and register admin. Right, so the first thing that, and this is now just showing you how the application works. So I'm just going to register a normal user. I'm going to say try it out. And so here I can just enter, it gives me the parameters that I need. So it's going to be, let's call this person Sue, and it will be Sue dot, and that will be Sue. And now I can enter my password. Now this system already does some checking for you. You can't just put in a basic password. It actually requires something from you. So I'm going to put A, B, C, which is using uppercase, lowercase, 1, 2, 3. And I'm going to be using that password. So I'm registering Sue as a normal user. I'm going to execute. All right, and what you now can see in your request, you can see that I'm making a request to register and I'm passing through that information. Now, so obviously you are passing in clear text, you are passing security information, and that is why it's so important to encrypt your communication with HTTPS so that that is not available. And you can then see, right, Sue has been created, so therefore Sue now sits in my database. Right, now I can log in. So I'm going to log in with Sue, and I'm going to try it out. And so I'm going to now say, right, Sue wants to log in. And she's going to log in with the password that we just created. Right, and there she is. Okay, and you're going to execute. Okay, so now what you see is, now this is amazing what the system does for you. You know, you saw how quickly I did the code and everything and how you set it up. And so here we see, okay, I've now logged in. There is Sue's credentials coming in. We've actually requested login. And so now returning is now my token. So here you see a token being returned. And this token now in the code, I didn't show you that, but in the code it says that the token should only live for 3 hours. It's an option that one can put. And you can see here, this token is now until 11:32 on today. So the token that I'm getting here is something that will only live for 3 hours, and then you can't use it any longer. So it's now 10, it's actually 11, so it's 1 hour. So perhaps, yeah, it's just for 1 hour. But yeah, so here we can now copy the token, and you don't copy you just copy it like that. So now this is the credential that you're being granted that can help you to move from point to point. So I'm going to copy the token, okay? And so then I'm going to just refresh everything. So now I'm going to log in here. I want to now access this resource that it has been protected. You can see that the resource has been protected with a role. If I remember correctly, it was admin, I think. So, we'll see what happens. So now I'm going to try this one out. Now, before I can make a request, I actually have to, you don't put any parameters in, but what I have to do is I have to add a token to this call, which I click here, and this is where the bearer authentication happens. So I'm going to put in the word bearer. You just type the word bearer space, and you paste in your token, and you say authorize. And now what you've done is you've actually added into the header the token. And so now you can say execute. Okay. And so what do you see? You see here that I'm making a call, and I'm making a call there with a token, but it says to me, sorry, you can't access. So basically it's telling me, sorry, you are not supposed to be doing this. And the reason for that is because the role has to be admin, and I'm not an admin person, so I can't access it. So yeah, so basically, I can quickly repeat the process. So we are going to register somebody who's admin. We are going to now there is a register admin here. So let's say we are now going to create an admin called Dave. Going to use the same password. Okay, so now Dave is created. So there is Dave. So Dave has been created. He's an admin person. And now Dave is going to log in. And there he's entered his credentials. And now he has been granted with a token. So there is Dave's token as an admin person. He's going to get that, copy that part there. Okay. And so now I'm going to actually go and see if I can access this as Dave being an admin person. Right, so I'm going to now enter my credential as an admin. Add it to the header. And I'm going to execute and hopefully, and we can see, yes. So now what we see is that because he's an admin person, he's got the role of admin, he's got a token that says he is that admin person. We can now see that Dave can actually now access the content of the okay, right, everybody. So I've now demonstrated this to you. So I just want to see if there are any questions in the chat that people have about this. Okay, so let's just see. Okay, so yeah, so we are looking at the categories table. That's what we have in our project. Okay, so yeah, so there's also a question of, you know, so what you now have to do is to understand what is required of you, you should study the brief of Project 2, which is very clear on what you have to do, and you should study the rubric. And you'll see that, you know, implementing security is one of the options. Much more important is to get the foundation right. You know, so if you're stressing about doing all of this, you know, let's just say what's the most important thing? Get the foundation right. So the first thing to do is to just get the basic project running on your computer and get it right. So take the demo from last week, work through it in detail, and make sure that it works, right? So when that works, the next step is then looking at all the videos that we've shown you about the cloud, making sure you understand it and see that you can host your project on the cloud. You know, then when that works and you're comfortable with that, then you can see how to implement the security in that project. You know, so at least if you are somebody that is struggling, just get the foundation right. Look at where most of the marks lie and then focus on that part and get it to work. So, and then after that, the next component will be the security, and the next component next week will be, but that's an optional component that you don't have to do, is the microservices part. So yeah, I think take it step by step, look at the marks, where is the mark allocation, make sure you do the foundation right, make sure you understand the cloud, that it does, you can log in, you can create an account for yourself, you know how that works, look at the videos on the cloud. And you know, so, but I think first of all, start and just do last week's demo and make sure that you've got all the endpoints there for each of the 3 database tables. That's the most important thing. It shouldn't take you too long. And then there's some additional endpoints that and sort of code that you have to write. And then from there, you can continue with the rest. So yeah, I think it's very important to get your foundation right. You have 2 weeks left. So start this week. Don't leave it for whenever, you know, instead of sitting around on Saturday, rather go and do your work and get it over and done with. Don't stress about, don't cause a lot of stress in your life because you procrastinate. You know, that's generally a problem that most people have, is they procrastinate. They leave things for the last minute, and a lot of these concepts have to sink in. It has to sink in. You have to do it again and again. You get comfortable with it, and then it's a skill that you've actually acquired, that you can use again and again. So spend time on it, look at what we ask, look at the content of the classes, and just, you know, do the little bit that's required every week. Right, so that is then all from my side. Is there anything else that anybody would like to say or mention? Yeah, there is a, like I said, there is a rubric. Okay, people, so that's all. We actually went a bit faster than planned, and so the recording will be available. I'm going to give you the guidance document on how to do security. So I hope you enjoy it. I hope you're going to, really implement Project 2 well, and you're going to be very proud of what you've done. So yeah, that's then all from us. Thank you.
Thanks, everyone.